Adi Ripaldi will be the chairman of the Climate Science Group, and Mr. Erwin Makmur will be the chairman of Ocean Science Group. Ladies and gentlemen, we remind you again, for Climate Science Group are requested to move the room to the link that will be shared in the chat room. So please check your chat room now. And for Ocean Science Group are requested to still stay in this room. We will have a 10 minutes break for parallel class preparation. I do hope our workshop today will be very useful for all of us. I would like to apologize if there is any inconvenience. Thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih. We did have a question.
Maybe inform also for Carl to move the. Pak Sini, actually we designed another room for the climate science, so including for Carl.
Carl, could you please follow a new link? That do you see the link in the chat room? There is.
Yes. So
yeah, this one. So could you follow that link?
We did have a question.
Yes,
could we
yes,
could
please.
we ask? Can we have a question and answer session before we break into
yes.
the two breakout rooms? We did have some questions. I see one here from NOAA colleague, so I can handle that question from Ken Connell. Ken is the RAMA project manager at NOAA's Pacific Marine Environmental Laboratory. He says this question is regarded to the report on the 2019 Prima Rama cruise that Wilmar presented. And Ken thanks Wilmar for the summary. I really enjoyed the presentation and the video. Ken Connell says in the evaluation summary, he noted that you listed two recommendations. One was permit in case of extreme weather, particularly at 15 North. And then the second point was intensifying transfer of knowledge. Could you please elaborate or provide additional clarification on the first recommendation regarding extreme weather at 15 North? Who would like to answer that question, please?
Do we have Wilmar here?
I think, yeah, he's here.
Wilmar, can you answer that one?
Wilmar monitor?
Yeah, he's in
Yes, yeah. He joined.
If someone could please unmute Wilmar, that would be helpful.
He already unmute actually. Arif, can you call it?
Maybe there's some technical error from his side.
Can you call Arif?
Yes. Should we wait? Okay. Maybe if it takes too long, maybe we can continue.
Yeah, we'll come back if Wilmar. Let's take some more questions, and Ken Connell, we'll come back to that when Wilmar is able to unmute. Are there any Bahasa questions, please?
There is none. There is no more question, I think.
Some text in Bahasa is about the information on the classroom.
Okay, yeah.
This is only
let's move on. But I would like Wilmar to answer Ken Connell offline, please. If we could take that action item. If Wilmar could just send an email to Ken Connell.
Yes.
Okay. I see no other questions. Bunelli and Padodo, is it okay with you if we go into our breakout rooms now?
Yeah.
Okay. Then if you're in the ocean science, we'll just stay here. And Carl Schreck.
I would. So, yeah, I think we are ready to go to the breakout.
Terima kasih, Pa.
Yeah,
We'll see you later.
For Pak Wilmar, later on you can answer Pak Ken. Yeah.
Great. Terima kasih. Have a good climate. I'll be in ocean session, Pa. So I'll see you later.
Yeah. See you
Yeah,
later.
Pak Dodo will be on the
Yeah,
climate
I'm
session.
in the climate room.
Okay. So I will pass.
Yes, please.
At this point, I'd like to invite Pa Irwin. I understand Pa Irwin will be chairing the ocean science group. So the floor is yours, Dr. Irwin.
Hello, Sydney.
Ah.
Okay, thank you very much. See you again.
Good to see you again.
By the way, I had a message from Dr. Chidong. He had some problem with his audio, so maybe now he left the group. So maybe.
Can you hear me?
Oh yeah, Chidong.
Yes, Chidong.
Hey, Chidong. Yes. I hear you.
Yeah.
Ah, you get the background also.
Okay. Okay, thank you, Sydney. So, Bunelli, can we start now?
I think we can. I don't know. I think we will stay for a couple minutes. Yeah.
Yes.
To make sure that the participants are already here.
Yes. Yeah, we still need wait a little bit. I'm sorry, I will speak in bahasa. Untuk yang baru datang, jika dari Klimat ada link untuk ke kelas Klimat. Terima kasih. Cek.
So maybe before we start, maybe I will check the present of the Pak Chidong.
Do you want me to share screen now?
No. Just to check. Okay, Pak Chidong already here, and then Prof. Golden. Are you copy? Monitor?
Yes, I'm here. Yeah.
Okay, thank you. And then Professor Janet?
Yes, I'm present.
Okay, thank you.
Thank
and
you.
then Bu Asmi?
Saya di sini, Pak.
Oke, terima kasih.
Untuk peserta yang baru datang, kelas Klimat bisa menggunakan link di chat.
Pak Arif, bisa dimulai, Pak?
Yes, I think we can.
Okay, thank you very much. Good morning and good night in US. So in this session, I will lead for this session with Miss Welly as the reporter. And then for this session, we have 4 outstanding speakers from US, and then also from Indonesia, but maybe half US. And then for each speaker, we have in total 30 minutes for presentation and then a discussion. And then because of the very tight time, so I hope you can arrange your presentation at the time. And then for the first presentation, we have Professor Chidong. Professor Chidong will talk about the YMC in Indonesia, some current status, and then the progress, and then next plan for Indonesia. Professor Chidong, I think you can share your presentation now. If you have some trouble.
Will you share your presentation?
Or I'll share the screen now.
Watch.
Can you see it?
Not yet.
Still not?
No, Pak Arif bisa bantu, Pak?
Ya, sebentar. Sebentar, Pak, ada kesalahan ini. Ada kesalahan file.
Oh no, I'm sorry. Before we start the meeting, so we need some remark from Bu Nelly, maybe for the preparation for Dr. Chidong. Bu Nelly, would you please to give some remark for 5 minutes?
I don't prepare any remarks. But I do hope that we can really get, we really have a fruitful discussion. And I think for BMKG or Indonesian Colors, I think we must really can get benefit from the speakers, all the speakers in the ocean class right now. Thank you.
Okay, thank you, Bu Nelly. So we will start our session now. And Dr. Chidong,
yep.
Maybe if you already share your screen.
Yes, I did. Can you see my slides?
Maybe still not.
So what do you see on your side?
Your face.
Oh, my face.
We can see you.
Okay, so in a Prima,
maybe the committee will help you to share your screen.
If you have,
they are sharing already. Lucky for us, there's no problem, and their work and our work as well. But because there's an event like that.
Okay, maybe
for the safetyness.
Okay.
Okay.
Can you see anything? My slide now?
Yes.
Yes. You may start now.
Okay, so I'll start. Thank you, Paul Irvin. Thank you, Nelly, for your introduction. So I'll take some time now to briefly update the recent progress of the YMC. Oh, I have a problem. I have a problem to advance my I don't know why. I have problem to advance. Oh, here we go. Okay, so I'm going to use these two cartoons to summarize YMC science. And in addition to remote influences from ENSO, for example, and the Indonesian dipole, Indian Ocean dipole, over the maritime continent, we have very rich spectrum of atmospheric and ocean variability. So that is illustrated on these two diagrams. On the left, we try to put as many as possible the larger scale phenomena. Where you can see my cursor?
Yes.
Yes, okay. So there's many different phenomena over the maritime continent. Here we have MJO starting from Indian Ocean, propagate over the maritime continent to the Pacific. We have the Indonesian through flow marked by those arrows. And we have a monsoon in both seasons. One is Southern Hemisphere summer monsoon, the other is a Northern Hemisphere summer monsoon. And we have a cold surge. Most of them come from north, represented by these cold front symbols. And we have warm air vortex. And in addition, we have many other synoptic perturbations such as equatorial waves. And of course, we have a lot of aerosol sources over the Indian Ocean. The figure on the right demonstrates the local air-sea land interaction on diurnal timescales. So as we know, at the daytime, most of the convection is over land, is tall but small. And overnight, the convection moves to the ocean and become a mesoscale convective system, become very large. And associated with this migration, diurnal migration of convection, we have a sea breeze during the daytime and land breezes during the nighttime. All those wind plus the larger scale monsoon wind and MJO wind will influence the surface energy and water fluxes. And over the ocean, we have very strong advection because of the Indonesian through flow. And we have very rich variabilities of internal waves. And all those activities will help the upper level ocean processes. So this is a very complicated system. And the YMC was designed to tackle all those multi-scale systems altogether. I always have problem to, okay, here we go. So globally, the maritime continent is very important because the MJO has global influence on weather and climate, as illustrated in this diagram. I'm not going to go through all the details, but you can imagine some of the lightning, some of the tornadoes, fire, so on and so forth. Maritime continent on the global scale. Okay, so in the rest of my talk, I will focus on the 4 parts. One is the field campaign, the data, publication, and the conferences. So I don't mean this table is for you to read details, but just generally tell you how many field campaign has been planned and how many have been complete. So you see this green box, everything in the green box are almost complete. And we have several ongoing and several planned in the coming years. And especially there are several field campaigns planned this year, but because the COVID-19 pandemic, then we have to postpone to some later time. Okay, so come back to this figure. I didn't mention what I didn't mention are those numbers. Each number represents the field campaign we just see on that table. What need to be pointed out is, as we are speaking, there's a field campaign going on near Palau, and that is conducted by GEMSTAC. That is their GEMSTAC second Boral Spring monsoon experiment. The research ship Marai is near 10 North, and together with other different instruments and platforms. And this field campaign has been going on for more than 2 weeks, and will complete by next Monday. Now let's talk about data. So there's 2 parts of the data. One is the data from field observations, and some of the data already available for public use. For example, all the GEMSTAC field campaign data are already released for public use, and they actually already conducted 3 different campaigns. One is pre-YMC in 2015, and the other one is 2017. The third one is 2018. And this one that is currently going is their fourth. And Jeanette will talk about ELO, and part of the ELO experiment is SIGA LiDAR observations. And those observations are already released for public use. And there are some ocean mixing profiles collected by a joint project of Japan, Indonesia, Australia, and China. And those data are also released. We know that the Australian investigator has conducted voyage in over the Eastern Indian Ocean in 2019. There are some of the data already released for use. For example, their ocean profiles and their radar data already open for public use. And the second part of the observations is from the operational network from the Indonesian countries. And that including radio sounds from 2017, 2019. Most of them are contributed by Indonesia, and some of them from Philippines, Singapore, and Malaysia. And Indonesian has a very nice network of land-based synoptic stations. They collect hourly observations, and now we have data from 2018, 2019. As Furkan just mentioned yesterday, BMKG has conducted the data quality control, and these data are almost ready to release for public use. Meanwhile, Indonesia has a large network of ring gauge with hourly data from 2017, 2019. And again, Indonesian scientists are conducting quality control for those data. And after that, those data can be released for public use. And there's some radar data from Darwin and from Pandan that has been used for research. And hopefully soon those data can be released for public use. As we know, we have the CMORPH satellite data, very high resolution, 30 minutes and 80 kilometers from 2003, and that has been released for public use. So those are the data, and we have a huge amount of data that has not been released, and I'll discuss that in a moment. So this just give you some examples for people who are not familiar with the regional network. Those are the sounding networks, and different color represent different devices. And it's a huge task to compare different type of soundings to make sure we have a good calibration and a consistent data quality. This is the Indonesian surface station network. This is very valuable. They have some inland, some on the coast, and I pretty much anticipate this data will yield very interesting scientific results. And this is the ring gauge data, very dense ring gauge data, which has been used to validate CMORPH, as we heard from Yessi yesterday. This is the radar network. At this time, we only have access to a limited number of radars because the huge amount of labor required. And hopefully, gradually, we can organize those radar data for scientific research and for prediction initialization. Let me talk about the special collection. Some of you may have known that we organize a cross-organization special collection for YMC. Cross-organization means this special collection has been joined by 7 professional organizations, such as AGU, AMS, EGU, AOMS, and so on. And this is the first time, as far as I know, and those professional organizations come together and agreed upon one single special collection on the chosen topic. And this is an experiment, and we'll see how it goes. So far, we have collected about 95 publications, and pretty much hope that some future publications authored by Indonesian scientists will be included in this special collection. Okay, so this is just an example. If you go to Jamstack YMC website and click special collection link, and you will see all publication in this special collection, regardless which journal or which from which professional organization, are all listed here. We call this a master list. So this is for the convenience of users. They don't have to go into each individual journals or in each individual organizations. They can just come to this website and get all the publication in this special collection. Okay, conference, as many of you know, we had totally 5 international YMC conference. The first one is kickoff meeting at Jakarta in 2014. And then we have 4 international workshops. And the 5th was supposed to be this year in Taipei. And again, because the pandemic, we have to postpone the next year. And since the starting of the YMC, there have been 36 YMC related meetings and sessions. For example, those are included in the AGU, AMS, and EGU, and so on and so forth. So we have been very active in scientific discussion and the exchange of YMC research results. All right, the last one is current issues. What we are facing now. Number 1, data archive release and user interface. We're still facing a huge amount of work to get all the data archived and released to public use, and perhaps build a user-friendly interface. And that's something we have to work on. We still need to continue capacity building. And in addition to training workshop, and I think a very effective capacity building would be through collaborative work and publications. And so we have a plan to do that, and we hope we'll see fruits from this collaboration. Observation modeling integration, that is the difficult part. We collect all the observations, how these observations can be used in modeling. That's something we have to keep in mind and work on. Field project, there's still some field projects not happening yet. There's still some IA need to be agreed upon and signed. So we have several major field campaigns still in the pipeline, and we hope they will be conducted successfully. The last one is research funding, and that is facing by both sides, by all sides. And without research funding, we cannot continue. So we have to work on that. So these are my quick summary of the recent progress of YMC, and I welcome questions and comments.
Okay, thank you, Professor Chidong. So you spent 15 minutes. Okay, we still have 15 minutes for question and answer. So for audience, please feel free to convey your question to Professor Chidong. So you may raise your hand, or you can chat via chat room. So let me check first. So
I need to stop sharing. Maybe can you stop sharing, Erwin?
Yeah,
oh, it's good.
Yeah, okay, thank you. Okay, we're still waiting for the question. So my the first question is, maybe I'm still very curious about the pandemic during the YMC campaign. So as you know that the YMC maybe still have very impact from the pandemic. So what is your opinion or your solution for this problem?
Well, certainly I have no way to stop the pandemic. I wish I could. So I think we just have to be nimble and flexible, and to get everything ready when the pandemic is over, when the research is possible, we have everything needed at hand rather than wait until that time to prepare. So, for example, use the Banda Sea cruise as an example. And I think we should continue form the research team, continue prepare on my side the research permit materials, and engage with the Indonesian scientists on the research topics, and so on and so forth. And we should get everything ready. And if we can identify the ship, and we can start working on how to configure our instrument installation on the ship. I mean, just have a general idea. So I remember I went to Jakarta to visit BJ1 and took a lot of pictures and bring it back to our engineers and consult with them to see where the instrument can be mounted. And if I cannot go there, if the ship can be identified, then I would ask our Indonesian colleagues to go on the ship, take pictures, and maybe get some deck plan maps to us so we can start working on the instrumentation.
Okay, thank you. We're still waiting for the question from the audience. So maybe you can raise your hand and then the committee will unmute you. Oh, Buneli, please.
Okay, thank you, Pak Erwin. Professor Chidong, as you already informed from your presentation, there are a lot of publications right now that are connecting with the YMC data. So actually, we do hope that colleagues from BMKG also will have many publications on this data. I think maybe you have a plan for our joint publication in yeah, maybe I don't know, this year, or how we can move for that. Thank you.
Yeah, I think we need to have a solid plan for that. So up to this point, what we have been doing is to form Indonesian research team, and each team work on certain topics, and hopefully they will have publishable results. Then we can write manuscript together. That's one possibility. The other possibility I'm thinking is to open the data, the BMKG data, for public use, but then request anybody use those data would include Indonesian scientists as co-author. So that probably will accelerate the process of publication. Even in that case, maybe those publications will not be first authored by Indonesian scientists because they are initiated from outside. But still, those publications will have Indonesian co-authors. So we can maybe you can consider whether the second option is will work or not from your perspective.
Okay, thank you. So, is there any question? So, Professor Chidong, so you mentioned from your presentation that Indonesian is very complex, and then you mentioned about the MGO barrier of Indonesia. So, would you please to explain more about the what does it mean the barrier for MGO in Indonesia?
Okay, so most of the MGO events start from the Indian Ocean and propagate eastward, right? The traditional view is MGO propagate over the maritime continent, become weaker, but then re-emerge over the Western Pacific and continue to move eastward. But then if you look carefully, you will find up to 40 to 50% of MGO events that formed over the Indian Ocean did not propagate through the maritime continent. They just died over the maritime continent. And that is a big mystery. We do not understand why. And that's that's a topic of very intensive research at this moment. So that's why it's called a barrier effect. So it prevents some undue event from propagating through.
Okay.
Can I have a question? Just
Yeah, please.
short question.
Yes, please.
Okay. Pak Cidong, so my interest is I want to identify barrier layer in Bandasi because I could see that impact of low surface salinity in the SST. So are you gonna measure S and salinity and surface temperature in Bandasi during the YMC field campaign?
Yes, we will. Yes, we will.
Okay.
So I saw.
I think there is a question from Agi. Pak Erwin.
Agi has a question.
Yeah.
Yeah. Okay. I can maybe I'll repeat that question.
Yes.
So
Please.
ask how to maintain the sustainability of post YMC research program. As we know, a lot of data and work has been produced. Is there a scenario of collaboration outside of YMC that it can be strengthened? It's a very good question. There's two parts. One part is how do we continue the YMC work? So far, YMC started with 1 year, right? And extend to 2 years. And now extend, just keep extending. Now we're talking about a phase 1 and a phase 2. So in our discussion, we think the phase 2 should be led by maritime continent countries, and they should own the program. And the people, international partner can join as partner, but the program should be owned by maritime continent countries. And that's one way to sustain the activity. I'm pretty sure the YMC problem cannot be solved within a few years. It has to be a long research effort. And you heard Professor Gordon talk about how much effort, how much time he spent to work on the Indonesian through flow. And consider there's many more phenomena all tied together. We probably need a whole lot of time to get things addressed. I think there's other.
Okay, we still have 2 questions, but we only have 2 minutes for answer.
Okay, I see. If I can go quickly.
Yeah.
So one will ask, I have a question regarding the MGO generation. Do you see if the air-sea interaction play a key role behind, or in purely atmosphere disturbance? Okay, so we had a field campaign over the Indian Ocean called Dynamo, and from that field campaign, we measured several MGO initiation over the Indian Ocean, and the result showing ocean plays an important role in MGO initiation. For MGO propagation through the maritime continent, to what degree the ocean plays important role and is still a subject of research. And Furkan has a question. My connection is not, I cannot listen clearly. Oh,
yes.
For all publications related to YMC, can you share the reference? Sure. All the references are listed in the YMC webpage of GEMSTAC. So if you go to GEMSTAC YMC page and click special collection, you see all the references there.
Okay, I think the question is already end. So because we have very limited time. So thank you, Professor Cidong. And then if still have a question, so maybe you can answer by chat room to the audience. Okay, thank you very much. Yeah. So the next presenter, we welcome Professor Gordon to present some research activity over Indonesia. So, Dr. Gordon, are you here?
Yes, I'm
Okay.
here.
Yeah.
Would you share screen or is it us again?
Okay, I'm going to try to share my screen.
Okay.
Sometimes it doesn't work. You know, host enabled attendee to share. Oh, so the host has to enable it.
Yes.
What is it?
Yeah, sorry.
Should I try it again?
Yes, please. Yes, please. Sorry.
Yeah, I know. They're, oh boy. How in the world do I pick this thing up here? No, it must be, I don't know. I'll give this one a try over here. Yeah, this is it. Share.
Yes,
All right.
Yeah.
And then
Already
play.
Yes,
Okay, yeah.
we can see.
How do you like that?
Okay.
Oh boy. Unfortunately, that's not the first slide. Okay, there's the first slide. Okay, Minty, measurement and modeling of the Indonesian through flow, the ITF. And as I mentioned yesterday, and others too, is the maritime continent is a very complex region of islands of different sizes, mountains of different heights, sea passages and straits of different widths and depths. And the higher Pacific sea level or pressure in the Pacific drives just tropical Pacific water through that complex region into the Indian Ocean, and it's part of a large global interocean network of sometimes thought of as the conveyor belt. The ITF averages probably about 15, but obviously it has variability across intra-seasonal and seasonal, interannual and interdecadal. And the more we look, I'm sure we'll see longer periods of variability, but it's extraordinarily important in putting heat and fresh water into the Indian Ocean. The picture you see there on the left, so the gray arrows are the more or less a schematic of the through flow. Most goes through Makassar Strait, and that's split into various streams through the Sunda Islands, archipelago there, though there is some water that comes into the Halmahera Sea and the Molucca Sea and Lifta-Matola passages from those eastern seas, and that joins the Makassar flow that gets into the Banda and eventually gets out through Timor. And we also have, not shown so much on this, there's the South China Sea plays an important role in that. South China Sea is very low in surface salinity, very buoyant water, and that buoyant surface layer at times during the monsoon in the winter time, northern winter, and during El Nino times, that water injects itself into the face and pathways of the ITF and causes the surface layer, inhibits the transport in the surface layer to give a high transport in the thermocline, as I mentioned yesterday. By the way, Susan Whiffles is the lead research or PI for the Minty program, but she couldn't be here today, so she asked me to give a lecture. But there's other people on this on the workshop who are lined us who know about Minty, and maybe during the question and answer period, or after I finish my 15 minutes, they can chime in and correct whatever I say. Here's the temperature in the northwest monsoon. It's the winter monsoon with the winds coming from the northwest. And then the southeast monsoon in the northern hemisphere summer with the winds are coming from the southeast. Unfortunately, I dropped that arrow. And you're looking at surface temperatures there for these two seasons. There's the scale. And it gives sort of an idea of how complicated everything is in this in the maritime continent. There's a lot of variability of surface temperature, surface salinity too, but we're looking at temperature now. And what controls those surface temperature patterns? Well, obviously local and winds and remote winds that drive the pressure gradients and the through flow. The geography, the shape of the geography of the islands and the depth of the various sills play an important role. Ekman-induced, wind-induced upwelling or convergence or divergence, upwelling or sinking, advection. Air-sea fluxes of heat and fresh water, of course, are important, but so is tidal mixing. And the more we work in the Indonesian seas, the more we realize that tides are not just sort of a high-frequency noise. They really affect the through flow and the characteristics of the water that make it into the Indian Ocean. I'm going to go on to the next slide now. And the tides published earlier too is if you do not the outgoing long wave radiation is that central column of the reds and the greens, and if the clouds are high, then you have little long wave radiation, outgoing long wave, and it shows up as red in that. And over the central part of the maritime continent, it's not as red as it is on the Indian side or on the Pacific Ocean side. And that's because the surface temperatures in the maritime continent are a bit colder than what one would expect. And that's because of the tidal induced mixing. When you run a model with and without tides, you see that the models, though it's very dependent on the model, that the models do show that the tides tend to make the waters in the maritime continent slightly colder and suppress convection in the atmosphere more than the non-tide or the control experimental run. So the tides affect the air-sea interaction by causing cooler waters. They also, as I said yesterday, they also alter the profile of temperature and salinity as the inflow, mainly through Makassar, reaches the outflow into the Indian Ocean, and the residence time within the interior seas, about 6 months, maybe a year in some places, get modified by the strong mixing, tidal mixing. Here's a nice schematic, Mu and Sprintle, and maybe Sprintle can explain that more. And but basically, not only are we getting a complex surface temperature field due to all those things I mentioned, but also the salinity is strongly affected by seasonal and intraseasonal, seasonal, and interannual variability in rainfall. And during the first decade of the 21st century, we tended to be more of in a La Nina condition or a neutral condition, which we get more rainfall, and the salinities went down in that period. The through flow and the heat transport to the Indian Ocean went up and actually moved some of the Pacific heat into the Indian, as I spoke about yesterday. So these complexings of the surface temperature, the surface salinity play. Now this is from the ROMS surface salinity from the ROMS model. Now I don't know how to play the movie. I can stop sharing this, I suppose. Maybe later during the question I'll work on that. But we have a movie that shows this variability in the maritime continent. But you can see blue is obviously low salinity, 32 to 33, and the greens are the higher Pacific salinity in Indian, about 35, or something like that. And you can see that freshwater plug in the South China Sea spreading across the maritime continent, which gives that freshwater plug. But the eddies and the filaments are very evident in the model, as they are in the surface temperature field too. I'm going to go on now to the MINTI program. Okay, now so the MINTI program, it's a US program funded by the National Science Foundation. Susan Whiffles. Woods Hole is the lead PI. And also involved are Jan Sprindle from Scripps. He's online here today. From Lamont Doherty Earth Observatory of Columbia University. Rutgers University, Wilkin and Zavala. I think Zavala is here. I don't know if Wilkins is here. And the University of Washington, Reiser and Yang. And I know Reiser is here. And they can chime in later. Our primary Indonesian partner is BMKG, and Nelly Rita, she's here. But there's also other programs from other countries. The Australians are from CSRO and CSHOR, which I'm not sure what that stands for. We'll be putting out various floats or Argo type floats to measure velocity, shear, and that. And I'll say a little bit more of what we from the Minty are doing. And also we are coordinating a program with the various Chinese programs, which I think are with LIPI, which are primarily focused in those northeastern seas, Molucca and Halmahera and Lithmatola, but they are some moorings also in the outflow regions in Lombok and in Timor. What you're looking at on the map there, the blue boxes are the Minty moorings, Casa and Lombok. What's the other one? Shafri, and then Ambai, north of Timor, and the Timor Passage, southwest of Timor. There are some Chinese moorings in Lombok and Timor too. You can see the red boxes underneath. And the Chinese moorings, the red boxes up there in the northeast are shown. The circles are the various Argo profiles, the US floats that Steve Reiser is running that program are the blue, and the Australian shear floats are the green. And what they do, so you have we're measuring the inflow and the outflow over a 3-year time period, and the temperature and salinity with the moorings. The floats within the interior is telling how the inventory of heat and fresh water varies spatially and temporally over that period, how it's responding to variations in the inflow and the outflow. Move on. The present status of Minty. Implementation agreement is close to final. We've gone through various iterations of that, and hopefully we're very much near the final form to be signed soon, within a month or two, we hope. And that will allow the implementation of the field program. I'll go down the lower point. We hope that the moorings will be out in late 2021 or early 2022, perhaps early 2022 is the more reasonable one. As everybody else, the progress and of the program has been stymied by the COVID pandemic. We had various planning meetings. We had a meeting there, an AGU meeting in the Ocean Science meeting in San Diego in February 2020. The mooring designs are complete. Most instruments have been purchased. Float building is underway. Steve can say something more about that. Security clearance that we need after the IA is signed has been stalled because of the suspension of RISTAC and also the need finally to get to complete our IA implementation agreement. Clearly, the working and coordinating a complex program like that within Indonesia is not easy. It takes a lot of attention to the details to get this done, and but working together, and we can overcome these challenges through collaborations and coordinations with those other projects that I mentioned above. Next slide, boom. So the Minty modeling program, it's ROM-based. It has tides, which is fantastic. And maybe the modelers, if they're there now, Zavala, I think, is here. I don't know if Wilkins is here. Can say more about that later during after I finish or during the question and answer period. Let me go on. Right now, what the modeling is doing is bathymetry and resolution tuning are in progress. They're using the instant data moorings, the 3 years worth of moorings in the inflow and outflow, 2004 to 6 inclusive, and other data. They're tuning up the model to get ready. Capacity building and capacity development and knowledge transfer to Indonesia is high on the agenda and importance. We support Indonesian scientists' research capability, going to meetings, visits to the various institutions in the United States. Enhanced international standing of Indonesian scientists is high priority. All real-time data will be directly shared, of course, with BMKG. BMKG scientists will participate in the cruises, support for developing expertise for early career scientists, high priority. Joint workshops and presentations at international conferences are planned once the program is implemented. An active participation of BMKG scientists in the analysis of the buoy data. Visits to the U.S. institutions, Scripps, Lamont, Seoul, Rutgers, co-authorship of publications, of course. BMKG teams was supported to attend the AGU Ocean Science meeting. Training workshops are planned after the fieldwork has begun. Plans are forming around float data management at BMKG. Steve can say more about that. In preparation for the deployment of the Minty profiling floats. Arif Surya, BMKG, is the first Minty-supported graduate student and accepted at the University of Washington. And we hope he can begin soon. COVID, of course, is causing lots of problems and getting the proper visa and all of that. And he might want to say more about that, but we welcome him. Obviously, Minty will greatly increase the observational database and our understanding of the Indonesian through flow. There are plans for a rich set of training activities and collaborative seagoing work and analysis. As I said above, the program is just beginning. COVID, pandemic, delaying the mooring and ship-based field program, unfortunately. Good progress is being made on modeling, on the modeling activities. And we welcome our first Minty student. So thanks from the Minty team. There's all the names there, as I mentioned before. And so I guess I probably didn't use all my 15 minutes, but I think we could open it up to questions or comments from the other Minty PIs. Whoops.
Yeah, thank you, Professor Gordon. So we're waiting for the question from the audience. If someone has some additional information about the Minty, please share your information. So
I stopped sharing now, I think, right? Yeah, stop sharing.
Yes.
Okay, got it.
Okay. As you mentioned that the Minty will start at the end of the 2021. So, but at the same time, maybe Chidong also have some plan to go to the east. So maybe if this activity we conduct together,
Yes.
how the impact of the research? So maybe Chidong, can you make some comments?
We are, the Minty program will coordinate on ship time with the YMC. So it's for the float activity, particularly the set to put out.
Yeah. Professor Chidong, are you still here? Yeah, maybe we ask your comment about the the same time for the Bandasi activity and then Minty in the East Indonesian seas.
Can you hear me?
Yes.
Okay. I mean, that's our plan. Our plan is to conduct the YMC Bandasi cruise and the Minty cruise back to back. So that's our current plan, and there's still a lot of details to be worked out. For example, whether some of the ocean and atmospheric measurement can be conducted on both cruises to lengthen the time series. We have not got into those deep details because the for Bandasi cruise, we just crossed the important hurdle of get the IA agreed. And so once that is done, once the Minty IA is done, and then we can work together on more details. But definitely, that's our current plan. So we do conduct two cruises back to back.
So you mean that it is still have possibility to conduct together with Minty project?
That's our current plan, and I think I'm totally rely on Professor Gordon to find me a ship. I'm not doing that, and Professor Gordon is looking for a ship, and I hope whatever the ship he finds is available to me too.
Okay, it's a deal. It'll be one of the Brunei-Gyres. I hope Brunei-Gyre 8. That's very. That's what I've used before, and it's good ship to work from.
So I invite for the audience to make a comment or question. So yeah, from Miss Audia Aziza. So, Professor Gordon, can you read the chat? Yes. Yeah.
I'd like to. This one, I'd like to ask about the ITF. How strong the ITF affects the weather in Indonesia or around in comparing to other seasonal factors. It's interesting, because it's much of our work is how the atmosphere essentially, or how the larger scale affects the Indonesian through flow. But you can also ask then how the Indonesian through flow feeds back onto various things like that. And I think that's a very open research question right now. I suspect that obviously it's a coupled system, the ocean and atmosphere, and the atmosphere affects the ITF, makes it change seasonally and interannually and such, and its profile changes quite strongly. The way it changes with depth profile, and that most likely feeds back to the distribution of surface temperature, as I showed earlier, and that then interacts with the atmosphere and feeds back to the atmosphere. It's a coupled system. I think that a lot of work needs to be done to fully understand that coupled system and through a whole range of timescales. And it's data like this that we have collected, and the data we're going to collect in Minty that I think will give the fundamental understanding so that the models can be developed to properly simulate and predict that coupling between the through flow, the atmosphere, and the ocean in this case. So obviously that didn't answer that question, but yes, the ITF affects the weather.
Yeah, okay. Thank you.
So if I may, I would like to follow that. If I understand it correctly, the Rutgers participation in Minty is to run high-resolution ocean models.
Yeah.
So is there any plan to couple the ROM to an atmospheric model? So Javier is online. Maybe I put Javier on the spot and ask him whether there's a possibility to couple ROM to an high-resolution atmosphere model to address the coupling issue.
Yes, for the Minty project, can you hear me?
Louder.
For the Minty project, no, we're not doing any coupling with atmospheric models. The science objective of the project is to understand the water mass transformation So most of the focus in the modeling side is just to increase. Right now, the model that Professor Gordon showed is the parent model, and then we're going to have nested domains focusing on the straits and key areas to understand, to try to better understand the transformation of water masses. However, in the future, in the long term, we would like to couple that with the world model. ROMS has now some new capabilities for doing ocean atmosphere coupling. So it's relatively easy to set up that. And well, we're going to try to find some funding for extending this model into the coupled ocean atmosphere realm.
Thanks.
I see another question there. Is there any connection between?
Yeah, we still have many questions.
Yeah, is there any connection between the strengthening ITF current with the eddy current formations in the southern Costa Strait? Yes, in the case during the IOD. You know, and the monsoon. Very interesting to develop a couple regional ocean atmosphere model, of course. You know, so the MJOs I mentioned yesterday, and Ashmi will probably talk more about that later on in this session. As they cross the maritime continent, as many of them weaken, and they don't make it across. Many do make it across. From the ocean point of view, if the ocean is warmer, thermocline deeper, more heat content in that upper 100 meters or so, they have a better chance of making it into the Pacific than if the surface water is colder, which is generally when you have a shallower thermocline and the tides mix up that cooler water. Obviously, the topography of the land plays an important role. And the other thing with the IODs is that a negative IOD tends to form stronger MJOs. The negative IOD has more water vapor in the air column and more energy, and you get stronger MJOs during the negative IOD. This paper I was involved with a few years ago. And so the IOD and ENSO, IOD is somewhat independent of ENSO, not completely, but they then are linked into the MJOs, which then affects the Mikasa through flow. So I don't know. It seems to be all the answers to these questions that I have is that it's really complicated, and there are so many interacting and coupled activities going on. And I think what's coming out now is the intra-seasonal variability, the MJOs, is looming larger in importance of controlling much of the characteristics of the ITF. And as I said before, we collect the data. The floats are going to be important, the moorings are going to be important, the satellite data and all of that, as much as we can collect, and you develop and you use that to really sharpen up the models and make sure you got the title right in the models. And yes, what was pointed out, the models need to be fully coupled with the atmospheric models. And once we have that, I think we'll be in good shape. How long is it going to take to do that? I don't know. Probably more than a week. You talk, so it's a, but that's the intent. Everything is interconnected. Minty itself is not going to answer all the questions. They may provide some insight that will allow the proper modeling to be developed that then can delve deeper into the system. Let's see, what else we got here?
Yeah, we still have a question from Pak Agit. So he asked about the influence of the ITF for the rainfall over Maluku Island.
Oh, I see that. I don't know. So what's going on there is that in the Molucca area there, it's a, yeah, so it's, all right, now I better not get into that now. It's a, well, we'll increase the rainfall there. You sometimes get warmer waters going into that region than in other times. And I suspect that might have something to do with the variations in the rainfall. And I've seen some data about that, but I'm not fully up to speed on that one, so I can't really answer that one.
Professor Gordon, have you visit Maluku before?
I think so.
Yeah, Maluku is a very beautiful island, so you have to go to there.
Yeah, I've been all over. So, okay, what else we have here now? Lots of questions about Maluku. Maybe I'm not reading it right here.
From Pak Ibnu.
All right, anything?
Yes. From Pak Ibnu. We know that Indonesia has many islands with local wind. What is one of the difference in salinity due to warming ocean? And high salinity will direct ocean current to low salinity and produce rain clouds. And how Minty respond?
I don't know why you're asking me such difficult questions.
Yeah.
But I love to think about those questions. I do it all the time. It's a, it really was. There's the movie of Ram's model of surface salinity, and it's just a complex array of eddies and filaments and things like this. You've seen this in other areas too. So. And what happens when you get the low surface salinity, you get a stronger barrier layer, and the surface waters might warm up more because they're don't mix as deep, things like that. So I suspect when we're looking at that surface salinity, it does have some impact of something on the surface temperatures. And maybe you have that in the model too. I don't know if you have a movie that shows the surface temperature time series like you had for the surface salinity. They're probably related because it's the eddies that are moving it around.
Yeah, okay. Maybe we still finish, we have finished our first session in this session. So we have break for 5 minutes. So we will start again at 9:45. So please keep on your position, and then we will start again at 9:45. Okay, thank you everyone. So maybe if Professor Gordon, if you still have video, maybe you can share to the committee, and then we will display during the break time. Okay, thank you. And then we will see you again at 9:45. Thank you.
On the movie, good idea.
Yeah.
Let's see now, where is that?
Yeah. What movie is that, Arnold?
Oh, it's the surface salinity from the Ram's model.
Okay.
I really don't know where it is now, though. So it's not. No, I don't know if I can find it now. It doesn't show up. Let's see, do I have it? Right over here. You have that, Arif. The movie was sent earlier by Susan. Maybe you.
Okay, let's see.
Let me just do my share because I just opened it. There it is. Here it is. I don't know if you can see this now, maybe not. Share.
Yes.
Right, so I'm going to play it.
Okay.
I know, can you all see that? I think.
Yes.
Right. I think we can set it to music. Yeah, it's sort of all those extraordinary eddies and filaments of the river water coming out and the going through the various passages. There's a certain level of chaos, I suppose, involved with this.
So the color means temperature or salinity?
Salinity.
Salinity.
The surface salinity. If you can see the low salinity, well, this is January to September, the low salinity water from South China Sea, that's where we mainly have. It goes into the Sulu Sea and then into the Java Sea too during the winter time, northern winter. It reverses itself in the summer. All right. All right.
What time in US now, Professor Gordon?
East Coast, 10:43 p.m.
Wow.
So are you still strong to follow until the end of the session?
I doubt it. No, I go to sleep early and I get up early. So this is closer to the time I get up.
So how about the fire in San Francisco? Is very worse now.
Yeah, Janet, are you being affected by that?
Yes, there's ones in San Diego, just out west of us, and since it started on about Sunday, we've just had an eerie glow. We haven't seen, we've had ash. We're probably 30 miles from that area. We've had ash on cars at the beach, and everything, and it's just the light is a bit surreal. It's very, it's overcast because it's smoke. You can't smell it much, but it's there.
It's a lot worse up in San Francisco area, isn't it?
I think San Francisco has had it much worse, for a longer time.
When
we've got it in Seattle too.
It's right in Oregon and Washington, yeah.
Yep, we have it.
Rains usually arrive there in California. It's not until November, sort of.
Oh, I will start my screen. Yes, okay.
Okay, now time is now in 9:45, so we can start our session again. And then for this session, we have two speakers, Miss Janet from Scripps. And then at the last speaker, we have Miss Asmi. And then all of you have 30 minutes for presentation and then for the question and answer. So Janet, would you
Can-
please
can-
to start? Okay.
Are you seeing my screen?
Yes, we see.
You see my presentation?
Yes.
Yes, very good.
Fantastic. This never works that quickly. Okay, I'm just going to get rid of that, and I need to.
Your slide and your background is same.
Exactly, and you know that's Laketober, right?
Yeah.
That is where I was so hoping to be able to visit there and be with all of you at this meeting. I was last in Laketober in 1988 when I was just.
Wow.
Actually, I know. Was anybody born?
You have to go again there.
It was like I spent 2 months in Sumatra.
Really? Wow.
Yes. Just, I was just in like what they call now a gap year, just trying to decide whether to go to graduate school or whatever. And so, yeah, it was just lovely. So maybe next year we'll have it there. We'll just see.
We hope so.
We can all be together. That would be wonderful. So I'm going to talk to you today about the Equatorial Line Observation Campaign, or ELO, and this is mainly consisting of observations of subseasonal variability in the Indonesian maritime continent. Let's see how I can. Oh, there we go. And luckily, we've had 2 fantastic presentations from Chedong and Arnold. And so they've given you a lot of the background about the maritime continent. And so we know that it's in the center of the Asceni branch, the Walker Cell. It's, right in the middle of the Indo-Pacific warm pool. And it consists of many, many islands with deep basins and wide and shallow marginal seas. The islands have volcanoes, as you know, and, lots of strong topography. There's strong tides, enhanced air-sea heat fluxes and freshwater fluxes. And like Arnold has said, that it's closely coupled to the MJO, the monsoon system, ENSO, and the Indian Ocean dipole. And that all affects the circulation pathways and the air-sea climate system within this region, and in fact has a global impact. So there's multi-scale interactions of air-sea land phenomena that is happening in the maritime continent, but it's been sparsely observed before, and we have really a poor understanding of this variability, as Chedong has said, and in that sense, it's also badly represented in our models, and so that leads to large systematic errors in extended range forecasts. So that's not good for any of us. So the goal of ELO is to examine these multi-scale interactions. That's a summary of it. So as Chedong has mentioned, the propagation of the MJO eastward through the maritime continent is the least predictable part of the MJO life cycle. And it's referred to that barrier effect. And it could be, many people actually think that it's probably land, sea, air interaction occurring on diurnal timescales that may hinder that propagation.
I'm sorry, Janet, your screen doesn't move. Maybe I can share screen mine. Your screen doesn't change.
Doesn't it? What can you see?
Yeah, we still see the cover only. Maybe I can do it the share screen for you. We didn't see your next slide. We only see the cover, the first slide only.
Oh, really?
Yeah. So maybe I can do the share screen for you.
Okay.
Okay, I will stop this.
So should I do a new share?
Yes, I will. Please continue.
Okay. It says I cannot share screen.
Yeah. I'm the one that doing share screen. So just follow just say next if you want to move to the next slide.
I cannot see the slides.
Oh, you cannot see the slide. Okay, because we cannot see your slide after the first slide.
And I cannot see your slides.
Okay, maybe I will just stop it, and then please could you start sharing again?
Okay. Can you see that?
Yes, can you move to the next slide, please?
Yeah.
Can you see that?
Yes.
Oh, yeah, yeah.
Now it's good.
Oh, okay. So you were just listening to me talk before.
Yes,
you could,
yes.
Okay, but you get the gist of what I'm saying. So
yes.
That's okay. And so I was on this slide. So I'm now on multi-scale interactions, and that's what ELO is all about. So the building, so we're just talking about this barrier effect that Chidong mentioned. So the building blocks of the active phase of the MJO, actually these convectively coupled Kelvin waves, and that's the leading mode of the eastward moving convection, which occurs on roughly 3 to 21 day timescales and at speeds of about 11 to 14. And the most severe precipitation events in Indonesia are related to these CCKWs. So we think I will show some evidence that diurnal timescales, suggestions that diurnal timescales may be related to the propagation. But as Chidong mentioned, the ocean probably plays a role, right? And so it could be that it's influenced through the propagation is also influenced by SST or mixed layer variability. And that in turn modulates the surface fluxes. So our hypothesis as part of ELO then is to investigate the interactions of both the diurnal cycle of precipitation and the upper ocean stratification with the CCKWs that might be responsible for the breakdown in the MJO propagation across the MC, the maritime continent. So this is work from Darek Baranowski, and he examined the diurnal cycle due to land-sea-air interaction between Sumatra and Borneo. So this is a very interesting area because it's mountainous. It straddles the equator and it's surrounded by shallow seas. So in this this right-hand panel, we have the diurnal precipitation in millimeters per day, and that's the local morning in the top panel and the local evening in the lower panel, the local PM in the lower panel. And then on the right-hand panel, it's time of day going up the panel and longitude between going on the x-axis. So you can see that the maximum precipitation occurs over the ocean during the early morning, right? And that's shown here in this panel as well as in this panel, whereas over the land, the precipitation is maximum during the afternoon. And if we look at how that change in diurnal precipitation phase locks with the impact of the CCKW precipitation, it seems to impact the ability of the MJO system, of the CCKW system, to propagate across the maritime continent. And that's shown here in this right-hand plot, where we have longitude again on the x-axis, and this is Sumatra in this purple arrow region. And this is the mean precipitation anomaly associated with the CCKWs averaged over the passage of the wave. So in black is all CCKWs. In green are those CCKWs that arrive in the evening. And in red are the CCKWs that arrive in the morning. So you can see that over Sumatra, those events that arrive in phase with a local precipitation cycle, which we just saw was maximum in the afternoon, can bring 2.5 more times more rain and have a 40% better chance to successfully propagate into the Western Pacific than waves that arrive in the morning and so meet unfavorable condition. So that's a diurnal cycle, but like we talked about, the ocean processes matter too. So that can potentially happen through the salinity stratified barrier layers that develop during the active phase of the MJO in response to the heavier precipitation is one way they can form. And so we get these really fresh layers that occur within an isothermal layer, and the density is impacted by this salinity. So the density is strongly impacted by the salinity, so we get this really strong barrier layer occurring. And they can also be maintained during the suppressed phase of the MJO when the winds are weak. So if there is a barrier layer present, we don't get any cooling from entrainment from the region below the mix layer, because the temperature in, the temperature in the mix layer is the same as the temperature below it. So there's no change in the, no cooling from the MLD, and no cooling from the entrainment. And so we get this shallow layer that can trap heat and so influence the sea surface temperature and air-sea interaction feedbacks. And that was shown in this lovely paper by Kandaga Pujiana and Mike McFadden from 2018. And what they did was they composited some data from the Rama array at 095 East. They composited 15 different CCKW events, and they showed that the barrier layer doubles during the active phase of the CCKWs, and the turbulent heat flux diversion increased 2 to 3-fold. And so that's saying that these thick barrier layers during the active phase inhibit the downward diffusion of heat below the surface layer as well. In earlier work that we had done with Kyla Drushka while she was a student at Scripps, she formed NJO composites of SST anomalies dependent on whether the barrier layer was thin, that is less than 10 meters, or thick. And she found that during MJO passage, that SST anomalies are much warmer, they're much stronger when the barrier layer is thin. And that's the atmospheric forcing then is trapped within that mixed layer. So modulation of the SST by barrier layer thickness does impact the response of the ocean to the MJO, that in turn modulates MJO surface fluxes. And you could see that here. I'm not going to go through all the details in this, but it's in this paper, so that when we have a thin barrier layer, which we see here on the left-hand side, and these are the heat flux, the precipitation, the wind stress, zonal velocity, and temperature with the phase of the MJO. So this solid line is when the MJO is happening at 0 degrees, 90 degrees east. And when we have a thin barrier layer, we get a 15% stronger heat flux into the ocean, and wind stress is also stronger. And, with a thicker barrier layer, we see a 10% increase in precipitation. So this suggests this is a mechanism by which the ocean can impact SST, the upper layer, not just the sea surface temperature, but the stratification in that upper layer can impact SST and feed back to the atmosphere. So that's a goal of the equatorial line observation, to understand the key physical mechanisms that block or favour the propagation of the atmospheric convection associated with the MJO CCKW system across the Indonesian seas. So as I said, our hypothesis is that it's some sort of combination or whatever of the diurnal cycle of the precipitation and the upper ocean stratification that is responsible for breaking down the MJO propagation. So the planned DLO campaign was an observational field program focused on the equator, spanning from the Eastern Pacific to Borneo, and we had planned to have gliders in the equatorial Eastern Indian Ocean, enhanced MET measurements at 2 BMKG weather sites in Padang and another one on Pontianak in Borneo. And then we have 2 moorings, and that was actually my role in ELO, with the 2 moorings that would measure the stratification within Carimata Strait. So this was with the BMKG, Nelly Florida, and you can see the date there. That was our original planned goal, but just like we just heard from Arnold, fieldwork is challenging, no matter where you do it, it's just challenging. So in our update, the enhanced atmospheric measurements and gliders are really now targeted more towards Terra Maris, which is happening down south of Java. But the ELO oceans, the Carimata buoys, are still moving ahead. We had the IA signed in July, so that was great. A BMKG vessel was identified in Tanjung Pinang for a 2-day deployment. This is a schematic of the 2 sorts of moorings. And so we shipped those moorings in January 2020. That's what they look like in their little boxes. But then, just like Arnold has talked about, our deployments were really stymied by COVID because, with the RISTEC permissions being closed and just travel in general for all of us, international travel particularly is hard. So we're still planning, we're still hopeful. 2021 might be optimistic, but the buoys are there, so we'll just see. Benefits to Indonesia. It's just, we have capacity development and transfer of knowledge. Real-time data will be directly shared and controlled by BMKG. There'll be joint workshops and presentations at international conference. In fact, we hosted Effendi and Bayu as part of the Ocean Sciences meeting in San Diego, and saw this great presentation by FERCON at the Ocean Sciences meeting on ELO, and the active participation of BMKG scientists will be part of the analysis and publication of these data. So in summary, variations in the strength and timing of the coupled CCKW and MJO precipitation with the diurnal cycle and changes in the ocean stratification can lead to ocean and atmosphere responses that influence the maritime continent climate. So the goal of ELO is to prove our understanding of that whole system. So ELO Oceans plans for hopes for deployment of 2 buoys in Carimata Strait, January 2021 or 2022. We'll wait and see how things develop. So that's my story. Thank you very much for listening, and I'll take questions.
Thank you, Janet. It's very interesting to know about the South China Sea condition in near Indonesia. So as you mentioned that all the equipment already arrived in Indonesia, especially in Tanjung Pinang. So in this session, we want to thanks to the Tanjung Pinang station, BMKG station, and then to keep the maintenance and then keep all the buoy.
We are extremely lucky. We are extremely thankful for that, because it's just it's a challenge. It's a real challenge to try and coordinate everything, and so I thank very much Nelly and her team and you all for doing and making this happen. It will happen. If the buoys are Indonesia, are in Indonesia, I have full faith that this project will happen.
Yeah. As we know that the buoy already arrived in January 2020, so in this month maybe almost 1 year for the store. So do you have some what happened if the buoy still keep until maybe next year or next year? So is there any maintenance for, or we need to clean or something?
No, I think it's, we've asked this. So the buoys were manufactured by the Luca Centurioni's group here at Scripps. So you will have a talk by Luca tomorrow. And he thinks that certainly after 1 year, the buoys will still be okay. It may be, if it's after 2 years, we may need to replace some batteries and things like that, but we will work that out. We will adjust as needed. The instrumentation itself should be fine, and it's wrapped up very, as you saw. There's like I had that picture there of the shipment, and I think it's great, and it's out of the rain, So I mean, it's much better. You're keeping it much better than what I can.
Yeah. So we have first question from Pak Rudy. Yeah. So he asked in Bahasa, so maybe I'll translate to you. So which area ELO activity already done, especially for Indonesia? Is there in which area in Indonesia ELO already conduct some activity, or in other country? Yeah.
Okay. As I mentioned, the comprehensive complete ELO project will likely not be, it's not going ahead as planned. But Adrian Matthews, who runs the gliders as part of ELO, he was funded from his at UEA in the UK. He had deployed his gliders in between Christmas Island and the Indonesian EEZ. So that's what Chedong was referring to earlier. He deployed 2 gliders in mooring sampling mode, as well as in transact mode. And so all of that data is publicly available and has been, and Chedong mentioned that, and I think that that's available at the YMC website. ELO is one of the YMC projects that Chedong mentioned. So that is true. And then there's also, just because there are not the enhanced measurements at Padang, you are still taking measurements at Padang. And so that will be very useful for undertaking these measurements. So, and FERCON at Ocean Sciences presented some modelling results related to ELO. So there's definitely, we're still moving things ahead. So it's actually, like for many of us, it's quite productive being somewhat productive being in lockdown. It's frustrating, but we're not traveling, so we had that opportunity to do some science, which is fantastic.
Yeah. Okay. For your information, that at the same goals, maybe Jamstack's team, they also have to investigate about the monsoon of especially during the winter monsoon. Mm-hmm. So in next early 2021, we will launch the additional ration in Pangkal Pinang and Jakarta 4 times a day.
Fantastic.
So, yeah,
that's fantastic. So if we could manage, yes. So if we could manage to get the buoys into the water in that same time period, that would be fantastic to be able to look at that and the cold surges and all of these phenomena. So I think it will be just.
So by the pandemic, so Japan team cannot visit Indonesia. So the ration launching the conduct by Indonesian side. So I think, how about the ELO? So is it possible for Indonesian side to conduct all the deploy the buoy, or you have to visit to make sure that the buoy already?
there is a lot of preparation, the pre-preparation of the instruments, startups of the instruments and these sorts of things, and then communication that needs to be done to the instruments. The instruments, the buoys are returning information in real time, right, through Iridium to BMKG and partners. So there's some talking that needs to be done, but to the instruments, and that would take training. So I'm not saying that it can't be done like that. I thought about that. And I talked to my marine tech who about this as well. And we'll see. We'll play a bit of a waiting game for another couple of months and see how things develop. But yes, it could possibly happen through training. It'd have to be training via Zoom, obviously, because otherwise we'd be able to go. But that it's a very good suggestion. Thank you for that.
Yeah, so we have another question from Mr. Hafid. Maybe you can see in the chat room.
Yes.
Yeah.
Kafid? Yes, Kafid. Okay, is there any possible effect on the ocean turbulence in the case of the density differences that affect sea surface temperature dynamics in the shallow water areas, such as Carimata Strait? Do changing thermodynamic interactions cause the diurnal conditions of precipitation to change as well? I think that's a great question. I think that's a really interesting question. I think that Mike McFadden at Kandagar Pujiana and Mike McFadden have done a little, their paper addresses some of this, and they definitely see impacts from these barrier layers on the turbulent exchange of heat. And so I would refer you, Kafid, to their paper. I mean, it's a really lovely study of the impacts of the density difference and the feedback. I do, for the second part of the question, I don't have a good understanding yet, but maybe that's something that you could investigate. That would be, through a modeling study or something. I think that might be the way to go for that, addressing that issue. But there's lots of outstanding questions that, ELO has the opportunity to address.
Okay.
Okay, thank you.
Yes. Yeah, this is the last question from the audience. He asked about the ELO project. Why don't you go to the East Indonesia? You only go to the East Western. So how about the East Indonesia?
Yes, because so in some ways, some of the measurements that will be taken through YMC, the Bandasea cruises that Chidong talked about, they will be useful for understanding the propagation. And hopefully, again, I mean, if we could have everything out there at the same time, that would be fantastic. So I think, it's primarily because there's, everything's happening over Sumatra. Everything happens after Sumatra. And so the idea is to let's try and understand what's going on before Sumatra, on Sumatra, and then in the Carimata Strait. And so that's one of the rationales. I'd love to do it all. Maybe that's the next experiment, ELO 2.
Yeah. So the next question is how long the buoy will deploy in Carimata Strait?
Yes. Yes, it should. Well, we're primarily interested in the wet season, right? When the MJO and these CCKWs are present, which is probably November through March or something like that. So the mooring will be deployed through then, and then we will see how it performs and how it's performing and whether it lasts.
Yeah. We want to say thanks to Pak Dira Utama. They make some question for us, and then Pak Dira is the former of the chief of the Tanjung Pinang Meteo, and now he moved to the east of Java now in Banyuwangi. So we have successor now. So maybe we will continue this session for the next presenter, Bu Asmi. Thanks for Professor Janet, and then you may make some answer in via the chat room. Okay, thank you, Janet. And then Bu Asmi.
Thank you, Janet.
Yep. Okay. Bapak sudah bisa melihat?
Ya.
Sudah.
Yes. Okay. Ya, may start the presentation. Maybe mix nggak apa-apa, Bu.
Can you see my slides moving?
Yes.
Okay, good. All right. So, I'm Asmi Napitu, and actually my main institution is KKP, or Ministry of Marine Affairs and Fisheries of the Republic of Indonesia. But for now, I also work with Professor Gordon as a young associate research scientist. Okay, so today I'm going to talk about the general idea of SST behavior in the Indonesian waters before and during the MGO propagation over the maritime continent. So, Chidong Jiang has explained a brief description about the MGO. I'm going to do Indonesian version of that just for this part. Jadi MGO itu adalah atmospheric tropical convection. Biasanya berawal dari Indian Ocean dan kemudian mempunyai periode perulangan sekitar 20 sampai 90 hari. Okay? Dia berawal dari Indian Ocean, kemudian bergerak secara eastward dengan kecepatan 5 sampai 9. Ada dua fase daripada MGO, pasif kemudian diikuti dengan aktif. Ketika aktif, biasanya itu ditandai dengan hujan lebat yang kemudian mengakibatkan permasalahan Indonesia. Okay, that's a brief description about the MGO. So the Indonesian archipelago is along the pathway of the MGO, right? So the MGO impacts Indonesian weather and climate. Relate to that, I read every year and many times in the Indonesian newspaper about the BMKG press release related to the extreme weather due to the MGO. Let's see here, in 2018, the BMKG warned extreme weather due to the MGO. Again, in 2019, the BMKG explained the source of the widespread flood in Jakarta is MGO. And this is the most recent. So a couple months ago, the US Embassy in Jakarta gave a weather alert in their website. That was quite trending in social media at that time because US Embassy did not give this kind of warning frequently. So the BMKG explained that weather alert related to the MGO. So clearly understanding about the MGO evolution in Indonesian maritime continent is very important for BMKG because it helps to provide a better weather prediction. Okay, so in general, MGO is not well understood, including MGO evolution in the maritime continent. One of the prominent problem of the MGO in maritime continent is that continent act as a MGO barrier. So generally, only 50 to 60% of the total MGO can propagate through the maritime continent. And most of them got weakened over maritime continent. Many studies have tried to explain this issue, but only few include the role of the Indonesian seas in the MGO evolution. I'm an oceanographer, so my interest, of course, I want to see the ocean role on this MGO evolution. So I want to see first is SST. The SST is the important factors to dictate the MGO evolution. SST determines heat transfer from the ocean to the atmosphere. Any change depend on net surface heat flux and subsurface heat flux, which is controlled by oceanic process. So if you see this figure, this is an early indication of correlation between SST and MJO. As you can see here, is strong in Banda and Timor Seas. Okay, so in the next slides, I will describe SST role in MJO propagation over maritime continent, also MJO's impact on SST variation. So we track the MJO event that occurs from 1980 to 2012. For this study, we simply just using the RMM index to identify the MJO, and we use data from Troplex. And to control that data, we're using TRIM data. So during that period, we find there are 86 MJO events and about 60% event that propagate across the maritime continent. So it's only 60% of 86 MJO event that can propagate, and the rest of it is diminished in Eastern Indian Ocean. So here as an illustration, these figures show that the pace number based on the RMM index, okay? So we have 86 events that can propagate up to phase 3, but only 51 events can propagate into phase 4 and 5 region. Zhang, Chidong-Zhang, and Li in 2017 did similar thing, but they used a precipitation, they call it a precipitation tracking method to identify the MJO. So, beside of this, we also want to see how this propagation behavior based on ENSO condition. So we can see from this table, clearly La Nina years record more eastward propagation compared to El Nino, as La Nina correspond with warmer SST Indonesian seas. So based on that, my question is, does pre-existing SST in Indonesian seas play a role to help or block eastward MJO propagation across maritime continent? So let's see this figure. So from all 86 events that we had before, we want to see the SST condition over Indonesian seas during the MJO suppressed phase or pre-existing SST condition we see here. So we want to examine for two cases. First cases is when the MJO propagate across Indonesian seas, the 51. And then the second case is for the block MJO or fail to propagate. So in this upper panel is composite of all the eastward propagation event, and the lower panel is composite of the non-propagating events. As you can see here, if you compare these two panels, the upper panel is warmer compared to the lower. It means that a warmer SST condition precede the MJO events and that propagate into Indonesian seas. This warmer condition can be seen in particularly in Java, Banda, and Timor Seas. And then the propagation MJO event is about 0.5 to 1 degree Celsius warmer compared to the non-propagate one. Okay, so more SST contrast. For the two MJO cases, let's see more detail in Banda, Timor Sea, and Java Sea. Let's see the SST distribution, okay? So blue line is for the non-propagating, while the orange is for the propagating one, okay? So we can see here that high SST event in Banda and Timor and Java Sea occur more frequently prior to the MJO events that propagate into the maritime continent. The SST means also for, if you compare to propagating and non-propagating, is statistically different. All right, so we also want to see the diurnal variation. So diurnal variation contribute to the contrast between SST for propagation and non-propagation. As you can see here from these bar plots, the diurnal SST variation is more active during the suppressed phase for the propagating MJO case, particularly in Banda and Timor Sea here, okay? the diurnal SST variation here, we actually just using this equation from trough heat fluxes. All right, so warmer SST should translate into more heat transfer to the atmosphere. Now let's see the contrast, the surface turbulent heat flux for those two MJO cases. So warmer SST cause latent and sensible heat fluxes to be larger prior to the propagating MJO case. More heat fluxes increase the low level moisture content. So the MJO that propagate across the maritime continent is led by a condition over the Indonesian seas, where the SST is warmer, turbulent heat fluxes into atmosphere are more intense, and low level moisture is larger. So far, we know that warmer SST seems to be favorable for MJO propagation across the maritime continent. So now let's see what is the impact of the MJO when the MJO active.
Off dulu.
Okay.
Uangnya bingung. Hah? Baik kok harap dipilih.
Sorry Mbak Asmi, could you unmute your mic? Unmute your mic, please.
Okay, can you hear me now?
Yes, yes.
Okay,
please,
so let's see the SST respond to the MJO if the MJO active past Indonesian seas. First of all, I want to show you that intraseasonal SST in the Indonesian Sea is strongest in Banda, Timor, and Sulawesi Sea. But it's only Banda and Timor Sea that related to the MJO. Sulawesi Sea, it's not related to the MJO. It's just because it's due to the ocean process. Okay. Okay. So let's focus on the SST response in Banda Sea. These figures give an illustration for us if the MJO pass Banda Sea. So first, suppressed phase. This one is suppressed phase, and this one the active phase. So during the suppressed phase, we have OLR a proxy for the MJO. So during the suppressed phase, we have high OLR, it means clear sky, and then a low wind stress, and it causes SST warm. And then when the active MJO comes and we have a low outgoing long wave radiation because MJO convection, and then the wind is strong, it causes cool the SST by over 1 degree Celsius. So to quantify the importance of the surface fluxes to determine the SST, I'm using a simple slab model, which is expressed by this equation. The model simply use net surface heat flux and mixed layer depth data. So basically the results show that intraseasonal net surface heat flux account for about 70 to 80% of SST variance. The model SST reasonably agree with the observed SST, particularly during boreal winter, which is indicate MJO net heat flux dominate the SST. So from previous explanation, we understand that SST condition likely determine the ability of the MJO propagate across maritime continent. At the same time, when the MJO pass the maritime continent, the MJO influence the variation of the SST. So it's very important to understand the process that controls sea surface temperature. Most of intraseasonal SST variance in Banda Sea is controlled by surface heat flux. Ocean process, based on a previous study, we know it's only dictate 20 to 30% of the variance. So if you want to understand the complete picture of intraseasonal SST variation in Banda Sea, we need to understand intraseasonal variation of oceanic process that might influence the SST in Banda Sea. That include ITF. Why we need to understand ITF? Because ITF passing banda C, feed banda C. So the contribution of the ITF to the banda C SST is still unknown. So we need to learn about that. Other oceanic process, of course, ocean mixing and stratification. So this is one example. I just want to give an example of the impact of salinity on SST response in banda C. This is in banda C, okay? So the salinity surface satellite data, I'm using the satellite data as map for this study. I want to see SST respond to the MJO for two different salinity condition. First in low salinity, and then a second, the high salinity. You can see the SST response. Here's the SST response during the suppressed phase and active phase. You can see the SST response on the right for each of the SST conditions. So compared to high salinity condition, low banda C surface salinity correspond with a faster SST change during the suppressed phase and slower SST change during the active. So the slower SST change during the active phase maybe indicate that a low surface salinity create a barrier layer in subsurface that reduce subsurface cooling. Another example is the ITF. ITF can influence SST change and MJO evolution in the maritime continent. So far, based on our work published in 2019, we understand that the MJO can reduce the ITF transport, particularly in the surface. The change in ITF transport should translate into SST change, but we still have not quantified this yet. So the ITF transport goes to banda C. Therefore, banda C SST also should be influenced by the variation of the transport of the ITF. I think this is gonna be my interest for the future work during the MINTI. Here the summary. So I'm just gonna do this again in Indonesia. In bahasa. So, jadi saya sudah tadi menunjukkan bahwa SST itu sangat penting untuk mempengaruhi MJO evolution di Indonesia sih. Kenapa? Karena untuk precondition daripada MJO bisa lewat ke wilayah Indonesia itu kelihatannya adalah salah satunya harus temperaturnya itu hangat. Tapi SST itu dikontrol oleh surface flux, atmosfer, dan juga ocean. Jadi surface flux adalah faktor penting, but kita tidak bisa mengabaikan ocean process. So exploring the ocean process role in SST is my objective for future NJ research. MINTI and YMC and ILO field campaign will be key for collecting more information about the ocean process in the Indonesian seas. Thank you.
Terima kasih Bu Asmi. Saya rasa mungkin mudah-mudahan lebih dimengerti oleh teman-teman, soalnya ada campur-campurnya.
Yes, I'm taking benefit as an Indonesian, right?
Yeah. Okay, Bu Asmi, we already have one question from Pak Rudi Arif. Maybe you can see from chat room.
Okay. Okay. Wait. I think I have to stop share first. Okay.
Yeah. You can open the chat room and then
yes.
One question for you.
So MJO menyebabkan curah hujan yang sangat tinggi yang menyebabkan banjir. Mohon dijelaskan kronologis terjadinya curah hujan tinggi akibat MJO. Oke, so jadi MJO itu ketika pasif kita punya tidak ada konveksi kan, tidak ada konveksi. Kemudian ketika aktif ada konveksi, artinya kita banyak awan. Jadi itu salah satu itu yang menyebabkan hujan. Apakah MJO menyebabkan gelombang laut tinggi? Teorinya ketika kita mempunyai angin kencang, aku pikir ya seperti itu. Okay, I think I answered that in
Indonesian.
Indonesian.
Could you repeat the question in English?
Oh, of course. So about Rudy Arif Satrio asked me, NGO cause high precipitation, and then it caused flooding, especially in Jakarta. Could you please explain to me why we have a high precipitation due to this MJO? Can you explain more thorough, Pak Cidong? I have explained that in Indonesia, basically I'm talking about the convection, but I'm pretty sure you can explain it thoroughly.
Oh, you explained it very well.
No, you can explain that. Yeah, I'm trying to speak Indonesian because most of the participants are students. So I think I'm just going to take benefit as an Indonesian. So I can send the message to them.
No, I understand. I understand.
From Sydney Thurston, outstanding presentation, ask me yay. NOAA can provide surface drifter for band C deployment to observe SST, SLP, surface current 3D wave spectra, if that would be helpful. Of course, yay. From Bapak Arif Suryo, we know that the ocean responds slower than the atmosphere. So is there any lag time between the response from the band C to the strong event of MJO? From my study, it's about 2 weeks. So when the we have, basically I'm using the RMM index. So when we have the strong MJO, usually the SST will respond 2 weeks later. Yeah. Cidong, you want to help that?
No, I think your answer is right. Your answer is pretty much the same as what I see.
Yeah, is there any? We still have question.
Bagaimana kondisi SST di Banda saat MJO pada fase yang penyebabkan how's the SST condition in Banda when MJO so which MJO phase that cause dry in Indonesia? So how's the SST condition? So I'm not sure about that to answer that question because I don't think that if we have a dry passive phase means that we have clear sky, but it will cause a dry season in Indonesia. So I don't know. So we can ask Cidong later. So is the Janet? Is the salinity response in the Banda C during MJO propagation mainly respond to precipitation, or is there something else going on? It's actually one of my interests. I'm trying to see that from for this talk. Actually, I'm trying to see that from the Argo data, but I cannot see that. But I hope that I can see more data and I can answer that. It's supposed to be yes, but I don't know. I cannot show you the evidence for that. Mardiansa, apakah daerah propagation MJO dan daerah yang memiliki curah hujan berbeda dan surface wind berbeda ketika MJO? I'm not sure, but so he asked whether the propagation MJO and non-propagation MJO has a different precipitation, when the MJO active. So I simply use to track the my blocking MJO. I'm using the RMM index. Actually, Pak Chidong Jang is the one who used precipitation track. So I think he knows better about this.
Okay, we still have 4 minutes for question and answer. So, Bu Asmi, you still have many questions from the audience.
Yes, so Bapak Donald, in your presentation, you imply that the SST in Indonesian Sea is a factor for the MJO to propagate to Pacific Ocean. Are there any possible factors that may cause the non-propagate MJO, such as land surface fluxes, maritime and continent topographic complexes, and how this related to the MJO's barrier effect? So I think a lot of paper has explained about how the topography complex work as a barrier, or blocking MJO. So I think it's related to the moisture.
Yeah. So maybe we still have time. So maybe if you can repeat again for the question from Pak Mardiansa and Janet, maybe you can make some more detail for it.
Oh, Janet. Yeah. I think it's the salinity response in the Banda Sea during the MJO propagation, mainly respond to precipitation. I think so. That is like the main indication, because the precipitation usually help to build the barrier layer. But I don't have data that's good enough so we can see how the barrier layer develop in Banda Sea. But I think yes, but we really want to see the data to prove that. Dari Bapak Mardiansa, apakah daerah propagation MJO memiliki curah hujan berbeda, surface wind berbeda ketika MJO aktif? Yes. So there is so when the active phase we have more precipitation compared and then during the passive phase we have a clear sky. So for the propagation MJO, they basically has the same characteristic. They have active phase and they have passive phase, but whether they, in terms of intensity, I don't know whether the propagating has more intensity of precipitation compared to the non-propagating one.
Okay, maybe it is the last question because we still have only...
Ibu Asmi, apakah MJO bisa dideteksi sejak awal sebelum? Can you detect MJO earlier before it caused flooding? I think because MJO propagate from usually started from Indian Ocean. It's supposed to be we supposed to know ahead of time, but I'm not sure how we can predict how intense the precipitation is. But I think let's see, we can like tracking MJO when it's enter phase 3 and then they're gonna go to the phase 4 or maritime continent. But I'm not sure whether the MJO can detect. Can we predict how big precipitation could be in here? I don't know. Maybe Pak Chidongjang has a lot of knowledge about this. Pak Chidong?
Yes.
So one of the participants asked, can you detect how intense the precipitation when the MGO active and cross Indonesian seas? Because we want to, avoid flood in Indonesia.
Right. That is a big question, because as far as we know, when MGO is over the eastern Indian Ocean, the amplitude itself cannot tell whether the MGO can propagate through or not. So the strength of MGO only changes when it is over the maritime continent. So that's a very difficult question. So far, we cannot see, we cannot relate MGO strength over the Indian Ocean to MGO strength over the maritime continent. So in that sense, we cannot tell how strong the rain will be by measuring how strong the rain is over the Indian Ocean. And that's a great research topic.
But can you predict MGO before it enters maritime continents?
Depends on the model. Some models can, some models cannot. So far, the European Center model is the best to predict the MGO propagation.
Okay, thank you, Bu Asmi. Because of the very limited time, so we have to end our session. So again, thank you for all the presenters, and then please big applause to all the presenters. Okay, before we finish this session, maybe may I ask you to on your video, and then we make video. Not video. We make the photo session for all the participants. And then Pak Arif, can you capture the photo for all the audience? Yeah. Okay, please give your best smile for us, and then can end this session. Pak Arif, how many sessions can you capture? Pak Arif, you still unmute ya? Okay.
Fourth time.
Mbak Weli yang ini Pak.
4 kali Pak.
Okay. Mbak Weli, please.
Okay,
1,
2, 3. Okay.
Okay, finish. Okay, thank you. Thank you for everyone, for participant, for your active discussion. So we will end this session, and then we go to the maybe for pleno meeting again. I back to the Pak Arif. Pak Arif, silakan Mbak.
I think is there Mbak, ada Mbak ini Rima, mungkin bisa.
MC.
Mbak Rima ada di sini?
Langsung ke sesinya Pak Agi aja berarti.
Langsung aja mulai, mungkin Mas Agi langsung aja mulai.
Break dulu. Moderatornya udah ada.
Break dulu.
Oh, break. Ngopi dulu ya. Admin itu Pak Agi dijadiin kaos dulu biar silakan tadikan.
Arif, umumkan dulu break nih.
Okay, thank you everybody. We will have a 5-minute break before the next session start. For our US colleagues, thank you for attending. And I know that it's already late night there, so thank you for joining us.
Terima kasih. Thank you.
Thank you, Pak Sydney.
Thank you.
Thank you. Have a good session. See you tomorrow.
See you tomorrow.
Tomorrow, Pak Sydney.
Thank you, Nelly.
But you can still join
have a
if
good
you
Indonesian
want.
session. Good midnight.
So tomorrow we will use Zoom again.
Yes, yes.
Have a
Zoom
good night.
again. Yeah,
Cheers.
thank
Bye
you.
bye.
Bye-bye.
Thank you. Bye bye.
Thank you, Pak Arif Suryo.
Mas Agi, monitor.
Ya, Pak Supari.
Siap, mungkin kita bisa start 10.58, udah mau jam 12.
Oke, saya take over ya. Baik, sebelum saya mulai, saya ingin monitor Pak Aditnya sudah di room ini atau belum? Pak Adit, Assalamualaikum.
Ya, Waalaikumsalam warahmatullahi wabarakatuh. Ya, sudah, Pak Agi.
Oke, ready ya?
Oke.
Baik, saya mulai. Mohon izin Bapak Ibu semua, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera bagi kita semua. Semoga semuanya, Bapak Ibu dan rekan-rekan semuanya dalam keadaan sehat dan juga senantiasa tetap semangat di tengah kondisi pandemi ini. Dan saya rasa karya dan juga upaya dalam memajukan BMKG ini senantiasa kita lakukan setiap harinya. Dan sebelum saya lanjutkan kepada tim panitia, apakah akhirnya berbahasa Indonesia atau masih menggunakan bahasa Inggris, Pak Subari?
Indonelis.
Masih ada partisipan dari luar atau full Indonesia saja?
Mbak Asmi ini masih bisa bahasa Indonesia kan?
Nggak dijelas bahasa Indonesia, Pak. Tapi saya bisa ikut kan?
Siap.
Baik, kalau begitu disepakati bahasa Indonesia ya, Pak Supari ya?
Siap, Pak Agi.
Oke, baik, terima kasih. Baik, saya lanjutkan. Baik, terima kasih kesempatannya kepada Bapak Ibu sekalian di dalam 15 Annual Indonesia US BMKG-NOAA Partnership Workshop ini. Dan sekarang kita masuk pada sesi General Lecture, di mana Alhamdulillah sudah bersama kita rekan dan juga ahli dari BPPT, Pak Dr. Adit, yang insya Allah nanti akan saya perkenalkan. Sebelumnya saya ucapkan terima kasih juga kepada teman-teman semua yang juga masih tetap semangat untuk memonitor kegiatan ini. Sebelum lebih lanjut, saya ingin menyampaikan sedikit pengantar bahwa Pak Dr. Adit ini nanti insya Allah akan menyampaikan sebuah materi dengan judul Lesson Learned Weather and Climate Modeling dalam konteks case study National Laboratory for Weather Modifications, karena Pak Adit ini kawan lama dari BPPT ya, Pak Adit ya, dan sudah sekian lama mengoprek khususnya dalam kaitannya modifikasi cuaca. Sebagaimana kita ketahui bahwa modeling ataupun penghitungan numerical weather predictions di kawasan Indonesia ini adalah salah satu hal yang setiap waktu kita upayakan, karena tantangan terbesar dalam mengkomputasi kondisi cuaca dan iklim di wilayah tropis ini adalah banyaknya disturbance ataupun gangguan tropis yang seringkali sulit dihitung dalam kacamata numerik ya. Sehingga banyak sekali ataupun hingga saat ini kita masih melakukan menggunakan model-model dengan resources dari internasional yang mana banyak sekali resources yang saat ini juga semakin maju. Nah, tentu saja cita-cita dari kita semua bahwa harapannya sebagai masyarakat ataupun peneliti yang berada di wilayah tropis kita mampu ataupun memiliki model cuaca numerik di wilayah Indonesia, dan semoga dengan kolaborasi ini kita bisa turut mengembangkan ya dan juga terus memperkuat bagaimana NWP dapat diimplementasikan di Indonesia. Nah, sebelum saya ke pemateri sedikit, Pak Adit, saya bacakan kurikulum vitae-nya ya. Baik, pemateri kita pada kesempatan kali ini adalah Dr. Halda Aditya Belgaman. Saya biasa panggil Pak Adit atau Mas Adit. Dan beliau ini saat ini aktif masih di BPTMC ya, dulu PTHB. Sekarang selaku Koordinator Subbidang Hidrometeorologi atau Jabatan Fungsional adalah Rekayasa Muda Bidang Penerapan Teknologi BPTMC. Pak Dr. Adit ini lulus dari Kumamoto University dengan riset terakhir berjudul Variabilitas Spasial dan Temporal dari isotop stabil yang berasal dari presipitasi di atas benua maritim Indonesia. Sehingga saya rasa kontribusi penelitian yang dilakukan Pak Dr. Adit ini akan sangat besar ya untuk pengembangan deteksi ataupun perakiraan cuaca dan iklim di Indonesia. Sedangkan riset terakhir beliau ataupun yang telah terpublikasi ini ada program teknologi mitigasi bencana hidromet sebagai grup leader, yaitu mengerjakan terkait dengan prediksi cuaca dan metode evaluasi teknologi modifikasi cuaca. Saya tidak bacakan secara detail, secara umum, namun di sini saya ingin share sedikit ya Pak Adit ya, kontak jika nanti misalnya banyak pertanyaan yang tidak bisa kita cover dalam sesi kali ini. Bisa di email saja ke halda.aditya@bppt.go.id. Baik, untuk memperingkas dan juga mengefisiensikan waktu, insya Allah kita, kalau dari time range-nya kita sedikit molor 15 menit, tapi kita akan stick on kesempatan bicaranya Pak Adit untuk memaparkan range-nya 30 hingga 45 menit. Waktu dan kesempatan kami persilakan.
Ya. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera buat kita semua. Terima kasih Pak Agi sebagai ketua sesi ini atas kesempatannya, dan terima kasih juga kepada BMKG yang telah mengundang saya untuk berbagi pengalaman di dalam pekerjaan memodelkan cuaca dan iklim khususnya di Indonesia. Mungkin langsung saja izin saya share. Oke, mungkin saya tidak akan terlalu berpanjang lebar bagaimana teknis kami mengadakan atau menjalankan prediksi cuaca numerik di BPTMC, karena sebetulnya yang lebih ahli mungkin teman-teman dari BMKG ya. Kita pun di lapangan pada saat operasi modifikasi cuaca, teman-teman dari BMKG yang support kita mengenai prediksi cuacanya. Cuma di sini saya ingin berbagi sesuai dengan permintaan bahwa apa sih yang bisa kita ambil dari riset Weather and Climate Modeling ini, terutama di National Laboratory for Weather Modification atau Balai Besar Modifikasi Cuaca di Indonesia. Oke, sebelum ke topik utama, saya mungkin akan sedikit bercerita tentang apa sih modifikasi cuaca itu. Mungkin teman-teman BMKG sudah banyak yang mengetahui, cuma ini untuk refresh lagi bahwa modifikasi cuaca itu adalah intervensi manusia pada proses pertumbuhan awan di atmosfer untuk meningkatkan atau mempercepat turunnya hujan ataupun mensupres kejadian intensitas curah hujan. Jadi kata kuncinya adalah intervention on cloud development process. Jadi kita tidak bisa bekerja kalau tidak ada awan. Dan TMC atau teknologi modifikasi cuaca di Indonesia sendiri kita laksanakan untuk rain enchantment atau mempercepat proses turunnya hujan, rain suppressions ini untuk mitigasi bencana banjir pada umumnya. Kemudian untuk fire suppressions ini terjadi ketika kita menanggulangi bencana kebakaran hutan dan lahan. Kemudian di Indonesia sendiri dari tahun 79 kita sudah beroperasi hampir di seluruh wilayah Indonesia untuk berbagai macam fungsi atau kegunaan. Bisa untuk irigasi, pengisian air waduk untuk hydropower plant, untuk menanggulangi kebakaran hutan, dan juga untuk pembasahan lahan gambut pada saat kita melaksanakan operasi rain enhancement. Belakangan kita juga diminta untuk memitigasi bencana banjir dengan menggunakan rain suppression technology, dan beberapa saat terakhir juga kita ada request dari beberapa perusahaan pertambangan khususnya batu bara untuk bagaimana cara site tambang mereka relatif clear dari curah hujan yang tinggi. Terus bagaimana sih sebenarnya kita melaksanakan modifikasi cuaca atau cloud seeding itu? Jadi sebetulnya kita memanfaatkan proses pertumbuhan awan hujan. Jadi kita mempergunakan atau memanfaatkan proses yang namanya collision and coalescence di dalam awan itu sendiri. Jadi inti awan akan berubah menjadi tetes hujan apabila dia tabrakan dan bergabung dengan sesama inti awan di atmosfer. Dari yang butiran sangat halus, kemudian menjadi besar, dan kemudian turun jatuh menjadi hujan. Proses alami di atmosfer ini sangat bergantung dengan kondisi awan tersebut. Tapi kita bisa coba intervensi proses ini dengan memasukkan bahan semai higroskopis yang dapat mengikat uap air di udara untuk mempercepat proses koalisi dan koalescence atau tumbukan dan penggabungan tadi, sehingga proses terjadinya inti hujan di dalam awan menjadi lebih cepat. Tipe-tipe awan yang kita gunakan itu ada berbagai macam ya, tergantung dari inti awan tersebut. Inti awan ini akan menentukan bahan semai yang akan kita gunakan. Di Indonesia pada umumnya jenis awan adalah awan-awan hangat atau warm clouds yang inti awannya adalah butiran-butiran air. Dengan awan jenis ini kita mengintroduksikan bahan-bahan semai yang bersifat higroskopis seperti sodium chloride atau NaCl. Sedangkan ada juga awan-awan dingin atau cold clouds dan juga mixed phase clouds yang selain ada inti uap air, dia juga memiliki ice crystal sebagai inti dari awan tersebut. Nah, untuk awan-awan ini kebanyakan di lintang menengah menggunakan silver iodide atau AgI dengan tujuan memecah ice crystal tersebut menjadi butiran salju dan kemudian turun menjadi presipitasi ke darat. Selain cold dan mixed phase clouds, kita juga mengenal adanya polluted cloud. Polluted cloud ini adalah awan-awan yang mempunyai inti yang sangat banyak dan ukurannya seragam. Karena ukuran seragam ini, maka proses koalisi dan coalescence-nya menjadi sangat tidak efektif. Jadi kemungkinan turunnya hujan dari polluted cloud ini sangatlah kecil. Contoh polluted cloud ini adalah awan-awan yang terbentuk akibat aerosol, akibat asap dari kebakaran hutan dan lahan. Jadi kita bisa lihat sebenarnya asap-asap ini menumbuhkan awan di atas lokasi kebakaran, tetapi awan ini tidak memiliki inti uap air. Jadi awan-awan ini tidak akan turun hujan. Ini jenis awan yang kita hindari dalam proses operasi hujan buatan. Jadi intinya kita tidak bisa bekerja atau kita tidak bisa melaksanakan proses cloud seeding kalau tidak ada awan. Nah, dalam rangka ini untuk membuat proses hujan buatan itu menjadi efektif dan efisien, maka kami memerlukan sebuah tools untuk bisa memperkirakan kapan sih awan ini akan tumbuh ke depannya, atau di mana sih awan ini akan tumbuh ke depan, sehingga kita tidak istilahnya membuang-buang waktu dengan hanya menunggu kondisi kapan awan-awan potensial yang ada untuk kita semai. Dalam rangka itu, selain kita dibantu oleh teman-teman forecaster dari BMKG, salah satunya Pak Agi, waktu saya pertama kali masuk di UPTHB, Pak Agi sering ikut kita operasi di lapangan. Beliau provide data-data forecast di daerah target kita. Tapi di lain sisi kita pun di BBTMC sendiri mencoba mengembangkan numerical weather modeling dengan tujuan bukan untuk operasional tapi untuk bagaimana kita bisa lebih memahami proses pertumbuhan awan yang ada di atmosfer. Kita sudah lakukan itu sejak tahun 2010, bahkan sebelum saya masuk ke BBTMC. BBTMC pertama kali menggunakan MM5, kemudian beralih ke WRF model. Pertamanya kita menggunakan Linux cluster machines. Pada saat itu Linux cluster machine ini adalah banyak komputer yang kita paralelkan menjadi satu kesatuan komputer untuk merunning WRF models. Tapi dengan kemajuan zaman saat ini, single server pun sudah bisa merunning WRF model dalam rangka riset ya. Mungkin kalau untuk operasional agak susah kalau menggunakan single server. Jadi tahun 2014 kita lebih mensimpelkan kegiatan riset kita menggunakan WRF EMS atau sekarang namanya WRF UMS. Ini adalah paket modul WRF yang kita anggap di BBTMC ini penggunaannya agak lebih simpel untuk proses riset. Kemudian kita juga mengeksplor bagaimana sih kita dapat mengenhance hasil WRF model ini, salah satunya dengan menggunakan data asimilasi. Proses data asimilasi ini kita kemarin dibantu oleh teman-teman dari bidang meteorologi di Puslitbang BMKG. Nah, bagaimana sih hasil WRF model yang kita jalankan terhadap kejadian nyata di lapangan? Ada beberapa studi yang sudah kita lakukan. Ini adalah Mas Ardi Arbain di tahun 2013 meriset tentang bagaimana banjir Jakarta di bulan Januari itu bisa dimodelkan oleh WRF. Jadi dia menggunakan dua domain besar, satu domain besar dan dinesting ke domain kedua dengan resolusi 10 kilo. Jadi dengan kemudian menggunakan input file dari GFS dengan resolusinya 0,5 derajat. Kemudian domain 1 ini dia dengan resolusi spasialnya sekitar 30 km. Kemudian di running dalam waktu 24 jam ke depan. Kemudian diverifikasi oleh data GSMAP dan juga reanalisis dari NCAR dan INCEP. Ini dari hasilnya, yang panel sebelah kiri menunjukkan hasil simulasi WRF model, kemudian yang sebelah kanan hasil curah hujan, observasi GSMAP dan juga angin dari data INCEP dan reanalisis. Secara umum, WRF model atau simulasi dapat memperlihatkan pola angin yang sama, tetapi posisi konvergensinya yang ditunjukkan oleh kotak merah ini posisinya agak sedikit berbeda. WRF simulasi WRF menunjukkan daerah konvergensi ada di sebelah barat dayanya Pulau Jawa, sehingga proses jumlah curah hujan yang cukup tinggi terletak di utara Pulau Jawa. Sedangkan aktualnya proses curah hujan, jumlah curah hujan yang maksimum itu terjadi di daerah barat Pulau Jawa. Kemudian ini analisis 3 jaman dari waktu period yang sama 17 Januari 2013 dari mulai pukul 00 sampai dengan pukul 14 local time dan Jakarta. Sebelah kiri wave simulations dan sebelah kanan dari GSMAP. Dari hasil ini kita bisa lihat bahwa wave simulations bisa memprediksi waktu yang sama dengan kejadian extreme rainfall, walaupun lokasinya agak berbeda ya. Lokasi puncak jumlah curah hujan yang paling maksimum itu ada di utara Pulau Jawa hasil dari URF, sedangkan dari GSMAP terobservasi di daratan barat Pulau Jawa. Kemudian tapi URF simulasi tidak bisa memprediksi kemudian berapa lama intensitas curah hujan ini bertahan. Di simulasi URF pukul 11 local time awan sudah meluruh, sedangkan secara observasi GSMAP hujan masih terjadi hingga pukul 14 local time. Kemudian Mas Ardi memverifikasi dengan contingency table dengan menggunakan probability of detections, accuracy, bias, dan false alarm rate value. Mungkin kemarin Mbak Yesi pun sudah membicarakan hal yang sama. Hasilnya WRF memiliki nilai probability of detection yang tinggi itu setelah 9 jam simulasi. Jadi selama 8 jam pertama itu kita anggap dia sebagai masih training data. Kemudian untuk interval time ke-9 sampai 16 dia memiliki nilai probability of detection yang lumayan tinggi. Baik dilihat dari nilai CSI, POD, dan false alarm rate value-nya. Tapi secara umum simulasi WRF di tahun 2013 tersebut cenderung inconsistent selama 24 jam running. Jadi hanya pada rentang waktu tertentu WRF model bisa memprediksi dengan cukup baik. Kemudian ini contoh kasus yang masih baru kejadian Jakarta di banjir di awal tahun 2020. Ini kami sudah menggunakan WRF UMS dengan inisial data GFS 0,2,5 derajat. Jadi dengan inisial time 30 Desember 2019, kita tidak menemukan adanya signal curah hujan ekstrim pada tanggal 31 Desember dini hari ataupun pada tanggal 1 Januari pagi hari. Ini T+3 setelah simulasi. Tapi besoknya pada runningan hari berikutnya dengan initial date-nya 31 Desember, sinyal hujan sudah muncul di malam tanggal 31 hingga dini hari. Ini menandakan bahwa long-term forecast simulations mungkin tidak begitu baik. Short-term forecast simulation akan memberikan hasil yang lebih baik buat kita apabila kita melihat dari intensitas curah hujannya saja. Tapi dari faktor lainnya seperti RH, tutupan awan, dan juga arah angin, WRF kembali menampilkan hasil yang lumayan baik. Jadi apabila kita melihat perbandingan hari sebelumnya dengan tanggal 31 Desember malam hari, RH-nya meningkat drastis dan juga kemudian tutupan-tutupan awan rendah dan awan menengah itu meningkat. Ini bisa menandakan bahwa potensi curah hujan cukup tinggi. Hal yang sama di hari berikutnya terlihat juga kondisi RH yang cukup basah di setiap lapisan, juga kondisi perawanan yang cukup banyak, dan sekarang sudah muncul sinyal dari curah hujan yang cukup lebat. Dalam 3 hari total curah hujan diprediksikan sampai dengan 214 mm. Ini kita ambil di satu titik ya, Jakarta, dengan koordinat sebagai berikut. Jadi kita tidak meratakan wilayah, kita hanya ambil satu titik pengamatan. Dengan resolusi kita di domain ini adalah 3 km. Kemudian hasil spasial curah hujannya apabila kita bandingkan dengan GSMAP, kita menemukan bahwa hasil model kita itu sangat underestimate. Curah hujan maksimum selama 1 hari atau dari 31 Desember 6 UTC sampai dengan 1 Januari 5 UTC, hujan maksimum di daerah Jakarta hanya berkisar antara 100 sampai dengan 150 mm. Dan kita tahu pada kenyataannya ada curah hujan di timur Jakarta atau di Taman Mini itu sampai dengan 200-300 mm selama 1 hari. Itu juga terlihat di data GSMAP. Jadi hasil simulasi WRF apabila dilihat dari intensitas curah hujan itu seringkali underestimate, dan posisinya sama dengan kasus yang 2013, agak kurang pas posisi konvergensi angin di Pulau Jawa. Terlihat kumpulan awan-awan hujan terletak di daerah selatan, sedangkan untuk pada saat kejadian itu curah hujan berkumpul di wilayah utaranya Pulau Jawa. Kemudian kita lihat apabila kita melihat pola angin lagi, simulasi WRF sudah menunjukkan hasil yang cukup mendekati dengan realita di lapangan. Yang gambar kang itu hasil analisis gradient wind yang saya ambil dari BOM untuk tanggal 31 Desember jam 7 malam. Di wilayah Pulau Jawa terjadi belokan angin. Ini yang seperti tadi Mas Agi singgung juga, kompleksitas cuaca di Indonesia itu sangat tidak beraturan, jadi sangat tinggi kompleksitasnya. Tidak hanya 1 atau 2 faktor, bahkan bisa 3-5 faktor yang mempengaruhi itu, yang mungkin mengakibatkan simulasi-simulasi numerik yang di BPTMC jalankan sendiri kurang begitu bisa menggambarkan hasil realita di lapangannya. Seringkali selama ini kita tahu bahwa banjir Jakarta diakibatkan oleh MGO, cold surge, dan fenomena lainnya IOD negatif. Cuma dengan pola angin yang konvergensi pun sudah bisa memberikan dampak curah hujan yang cukup tinggi di wilayah kita. Jadi itu salah satu poinnya, bahwa memodelkan cuaca di wilayah kita itu mungkin butuh effort yang sangat tinggi. Kemudian ini kerjaan kami 2 tahun lalu dengan awal tahun 2019, kita berpikir bagaimana kita bisa meningkatkan hasil simulasi dari WRF dengan cara mengasimilasikan data observasi. Karena kami di BPTMC memiliki instrumentasi radar cuaca, maka kami kita coba asimilasikan data radar cuaca yang kita punya ke dalam WRF. Jadi kita menggunakan WRF 3D VAR atau modul data asimilasi dari WRF. Jadi kita gunakan sebenarnya ada 2 mobile radar, pertama X-band Doppler radar dan juga X-band Dual Polarization Weather Radar atau Furuno radar yang memiliki jangkauan spasial antara 50 sampai dengan 70 km. Kegiatan ini kami mendapat asisten atau bantuan dari teman-teman di Puslitbang BMKG, khususnya di bidang meteorologi. Kebetulannya Pak Donaldi mengasis kita bagaimana kita mengasimilasikan data radar cuaca ke dalam simulasi WRF. Domain yang kita pilih masih sama, interest kita di daerah Jakarta. Kenapa? Karena disitulah kita pasang radar cuaca kita. Jadi daerah interest kita pilih berdasarkan ketersediaan data radar yang kita punya. Jadi daerah center domain kita samakan dengan titik radar Furunonya. Input data yang kita pakai masih sama dengan GFS data 0,25 derajat, dan juga kita tambah dengan data DBZ dari data observasi radar Furuno. Pertama kan kita merunning WRF terlebih dahulu dari data GFS, kemudian keluar forecast yang pertama. Data forecast pertama ini kembali menjadi inputan di WRF 3D VAR dengan ditambah dari data radar yang sudah diproses sebelumnya. Setelah simulasi yang kedua tersebut, barulah kita mendapatkan hasil produk forecast WRF dengan menggunakan data asimilasi radar Furono. Tidak banyak skema yang kita rubah saat itu, karena kita hanya ingin mengetahui apakah ada pengaruhnya bahwa kita menginputkan data observasi ke dalam data WRF. Jadi kita menggunakan skema microphysics Morrison to moments dengan skema cumulus key, lalu boundary layer skemanya kita gunakan YSU, Yongxian, kemudian RRTM dan Dudia untuk skema radiasinya. Hasilnya mungkin hampir sama dengan kasus sebelumnya. Secara umum, yang panel kiri memperlihatkan hasil forecast dengan data asimilasi radar cuaca, yang tengah memperlihatkan hasil forecast untuk tanpa data asimilasi atau forecast pertama. Kemudian yang paling kanan adalah curah hujan dari GSMAP pada tanggal 18 Februari 2019. Bila kita lihat sekilas di domain satu ini, tidak ada perubahan yang signifikan antara sebelum asimilasi dan setelah asimilasi. Tapi secara umum, pola hujan yang terbentuk sudah menyerupai aslinya yang terobservasi di data GSMAP. Walaupun nilainya kalau yang sebelumnya underestimate, ini kita sangat overestimate rainfall intensity-nya. Kemudian apabila kita perjelas ke domain 2 bahwa input data radar ke dalam simulasi WRF ternyata mempengaruhi hasil. Jadi ada beberapa intensitas curah hujan yang berbeda antara sebelum asimilasi dan juga setelah asimilasi. Tapi perbedaan yang ada tidak begitu signifikan merubah hasil simulasi WRF-nya secara umum. Kemudian sama juga WRF simulasi ini sangat tidak konsisten. Jika sebelumnya kita hasil intensitas curah hujan menyerupai hasil observasi GSMAP, tapi pada tanggal 21 Februari kita coba lagi, hasilnya mungkin agak berbeda jauh dari observasi GSMAP. Kumpulan curah hujan di GSMAP terjadi di daerah timur batas domain, sedangkan untuk hasil prediksi menunjukkan malah di sebelah barat konsentrasi hujan yang ada. Jadi sangat tidak konsisten, walaupun kita tidak merubah skema yang ada, tapi hasilnya hari ke hari itu sangat berbeda. Ini adalah contoh data radar yang kita gunakan. Data radar yang kita gunakan hanya satu scan data yang kita ambil pada satu PPI level pada satu waktu scanning. Jadi hanya satu data saja, kemudian kita masukkan ke dalam WRF simulasi untuk running 12 atau 24 jam ke depan. Yang bisa kita ambil dari kegiatan kita kemarin, mungkin kalau kita cuma nambah satu data observasi, satu titik data observasi ke dalam simulasi yang cukup besar domainnya, mungkin tidak akan banyak mempengaruhi atau tidak akan banyak meningkatkan hasil simulasi itu sendiri. Mungkin akan beda hasilnya dengan apa yang dikerjakan oleh teman-teman di BMKG yang saya tahu mencoba mengintegrasikan seluruh radar cuaca di Indonesia, kemudian data tersebut dimasukkan ke dalam simulasi WRF. Yang kedua adalah workflow untuk mengasimilasikan observasi data ke dalam model. Dengan resource yang kami punya saat ini mungkin agak sedikit memakan waktu yang cukup lama ya, karena dengan resolusi terendah kita 3 km itu membutuhkan daya komputasi yang cukup banyak, sehingga apabila kita menggunakan itu di operasional atau melihat hari per harinya, mungkin tidak akan terkejar waktunya. Kemudian ini pekerjaan yang baru kita lakukan, kita dengan simulasi yang ada, coba kita kaji parameterisasinya. Kita coba cari parameterisasi yang terbaik untuk kita pakai di wilayah Indonesia itu, parameterisasi mikrofisik atau parameterisasi kumulus seperti apa yang bisa kita gunakan. Pertama kita coba cari di literatur, sudah banyak peneliti-peneliti lain yang mengkaji ini, bagaimana best practice-nya parameterisasi itu dilakukan di dalam simulasi WRF. Pak Indra Gustari di tahun 2012 untuk wilayah Jakarta dan Jawa pada umumnya menyarankan best practice WRF itu menggunakan skema microphysics Morrisons dan skema Cumulus Titke, sedangkan Arba'in di tahun 2015 yang menemukan bahwa yang memberikan hasil lebih tinggi adalah skema Goddard di microphysics dan Titke juga BMJ di skema Cumulus. Kemudian UKAR sendiri mengadakan survei bahwa parameterisasi apa sih yang lebih sering dipakai oleh user-user WRF. Untuk skema microphysics ternyata skema WRF Singles Moment 6 atau WSM6 itu adalah skema yang paling banyak dipakai. Kemudian untuk skema Cumulusnya, skema Kain-Fierz menempati tingkat pertama di kalangan user WRF. Kemudian kedua baru skema BMG untuk skema Cumulus. Untuk kasus di BBTMC, kita kemudian memvalidasi hasil WRF kita untuk 3 daerah. 3 daerah ini dipilih karena kita seringkali beroperasi di sana. Yang pertama di daerah Pulau Jawa, yang kedua di Sumatera, dan ketiga di Kalimantan. Untuk metode verifikasinya sendiri, selama ini kita menggunakan GS-Map, cuma mengingat sebaran stasiun pengamatan curah hujan BMKG di Jakarta khususnya dan Pulau Jawa agak cukup rapat, maka kita putuskan untuk memverifikasi contingency table WRF dengan data observasi di permukaan. Sedangkan untuk wilayah Sumatera dan Kalimantan, kami tetap menggunakan data-data dari GS-Map. Hasilnya seperti ini. Secara ringkas, untuk keseluruhan, skema Cumulus yang paling baik itu adalah skema BMJ. Ini kita laksanakan pada saat puncak musim hujan, sekitar bulan Januari hingga Februari. Dengan untuk skema microphysics-nya, skema microphysics Morrison memiliki probability of detection yang paling tinggi. Bahkan di wilayah Jawa, probability of detection skema BMJ untuk skala Cumulus mencapai 100%. Kenapa kami pilih Morrison microphysics schemes Morrison yang untuk kita gunakan di dalam model berikutnya? Karena sedangkan di wilayah Jawa sendiri probability of detection paling tinggi adalah skema New Thomson. Karena untuk sekali running di wilayah Kalimantan itu nilai probability of detection-nya sangat rendah dibandingkan 2 daerah lainnya. Daerah lain di atas 70-80%, sedangkan untuk wilayah Kalimantan probability of detection-nya hanya di bawah 60 atau 50%. Skala Morrison memberikan skema Morrison memberikan nilai probability of detection yang paling tinggi. Kenapa di Kalimantan probability of detection-nya sangat rendah? Itu pun menjadi pertanyaan kami. Ada kemungkinan bahwa faktor topografi di Kalimantan yang berupa flatland turut mempengaruhi hasil simulasi karena kami tidak merubah surface layers skemanya. Mungkin apabila kita memainkan atau merubah-rubah skema dari surface layer di Kalimantan yang berupa dataran, tidak ada pegunungan seperti Sumatera dan Jawa, kemungkinan bisa memberikan nilai probability of detection yang lebih baik.
Dit, reminder kita punya sekitar 10 menit lagi untuk paparan ya, Pak Dit.
Oke.
Terima kasih.
Terima kasih, Agi. Kemudian, secara kesimpulan OWRF itu, kita bisa bilang bahwa tidak ada 100% akurasi di dalam numerical weather program, apalagi predictions, apalagi di maritime continent. Oleh karena itu, kita tetap menggunakan forecast ini, tetapi tidak fokus kepada intensitas curah hujan. Kita melihat bagaimana prediksi pola angin dan juga humidity di target area kita, apakah pola angin dan humidity itu bisa membentuk potensi-potensi awan yang bisa kita gunakan untuk operasi cloud seedings. Untuk limitasi yang ada saat ini, maka pengembangan numerical weather predictions di kita sendiri sangat terbatas. Karenanya kolaborasi di antara institusi dan juga universitas itu kalau kami bilang mungkin sebuah keharusan ya, terutama di Indonesia untuk mendevelop lebih baik lagi bagaimana menghasilkan produk numerical weather predictions yang lebih baik. Tahun lalu atau 2 tahun lalu kami pun sempat diajak bergabung ke dalam program INA NWP yang diinisiasi oleh Puslitbang BMKG. Mungkin nanti kita bisa diskusi bagaimana hasil INA NWP tersebut. Kemudian satu lagi yang ingin saya bicarakan, ini udah bukan numerical weather predictions, tapi kita mendapat tugas khusus dari Pak Kepala, bagaimana kita bisa mencegah karhutla itu dengan memprediksi groundwater level di lahan gambut agar tetap basah. Jadi selama ini seringnya kita di BBTMC diminta untuk melaksanakan operasi hujan buatan ketika api atau hotspot sudah terjadi. Seperti kita tahu di gambar tadi, apabila api atau hotspot sudah terjadi, banyak asap yang dilepas ke atmosfer yang tentu saja sangat menghambat proses terjadinya awan-awan potensial. TMC bisa dilakukan, tapi mungkin akan lebih banyak diam. Kita benar-benar menunggu saat-saat yang sangat tepat ketika awan potensial itu muncul. Jadi proses TMC sendiri tidak efektif dan tidak efisien. Kita pinginnya dalam rangka pencegahan itu, kita ingin membasahi lahan gambut agar tidak mudah terbakar. Jadi sebaiknya dilakukan pada saat sebelum puncak musim kering. Banyak institusi yang sudah memonitor dan juga bahkan memprediksi ya, dan membuat warning terhadap karhutla. Cuma kita belum menemukan tools yang tepat untuk BBTMC sendiri. Bagaimana sih kita menentukan waktu yang tepat BBTMC untuk melaksanakan operasi hujan buatan dalam rangka pembasahan lahan gambut. Maka kami memutuskan untuk membuat sebuah program prediksi water level yang bisa menjadikan indikator buat kami bahwa ada saat yang tepat, misalkan di bulan Maret, April, Mei atau bulan apa, bahwa saat itu tinggi muka air tanah sudah mulai turun sehingga perlu dilakukan pembasahan lahan dengan cara proses modifikasi cuaca. Saat itu kami bekerja sama dengan IBM dan juga menggunakan data-data BRG, terutama water level monitoring di pilot project kami dilaksanakan di Sumatera Selatan. Jadi kami menggunakan data water levels di 5 stasiun untuk kemudian kami prediksikan menggunakan istilahnya advanced statistik lah kalau kita nggak bilang artificial intelligence. Inilah contoh datanya dari 5 stasiun yang kita dapat data, hanya 2 stasiun yang cukup memadai panjang datanya dan juga kualitas datanya untuk kita coba bangun sebuah model. Jadi dari berbagai macam algoritma kita sudah mendapatkan dengan menggunakan algoritma XGBoost, kita bisa memprediksikan dengan cukup baik kondisi water level di kedua stasiun tadi. Ini di stasiun Seleh 2 dengan data training dari awal bulan Juli 2017 hingga bulan Oktober 2018 sebagai data training, kemudian kita prediksikan sampai dengan Januari 2019. Terlihat dengan error sebesar 17%. Secara umum hasil model sudah bisa mengikuti hasil observasi tinggi muka dan juga hasil prediksinya sudah cukup baik kecuali di 3 minggu terakhir. Karena mungkin dari historical data yang kurang cukup panjang, maka model hanya mampu memprediksikan dalam waktu 7 minggu ke depan. Yang sama juga di stasiun Oki 2 dengan presentasi error setelah 11.78%. XGBoost algoritma juga terbilang cocok untuk diterapkan dalam memprediksikan tren di tinggi muka air tanah di lahan gambut. Ini adalah analisis cluster di Sumatera Selatan sebagai daerah pilot project kita. Kita memetakan ini dengan tujuan kita bisa mengetahui daerah mana yang terus berulang dalam kebakaran hutan. Maka daerah-daerah itu yang akan kemudian menjadi daerah prioritas untuk dilaksanakan penerbangan penyemaian awan. Ini hanya analisis korelasi antara water level dan juga hotspotnya sebagai proses dari data science yang ada. Kemudian tahun ini rencananya kita coba kembangkan model itu eskalasikan ke semua provinsi yang ada. Kemudian kita juga sudah bekerja sama dengan Pusitbang BMKG kembali, kali ini dengan tim dari bidang klimatologi untuk membantu kita memberikan insight-insight bagaimana sebetulnya kita melaksanakan prediksi iklim yang lebih baik dan juga dengan bantuan dukungan data-data prediksi iklim, terutama dari faktor-faktor iklimnya seperti curah hujan ataupun temperatur. Kita bisa artikan bahwa Advanced Statistical Method atau AI ini adalah metode yang bisa kita gunakan untuk memprediksi secara tidak langsung faktor iklim, terutama di lahan gambut untuk long term analysis. Kenapa kita butuh long term analysis? Karena kita tidak ingin melaksanakan operasi hujan buatan secara dadakan. Misalkan minggu depan tolong dibuat operasi hujan buatan di Provinsi Sumsel. Kita bisa aja cuma tanpa analisis yang cukup, kita kemungkinan tidak akan menghasilkan proses modifikasi cuaca yang efektif dan juga efisien. Kemudian tren di historical data kita bisa bilang merupakan faktor kunci ya untuk memprediksi masa yang akan datang. Dan development yang kita lakukan saat ini masih sangat awal, butuh banyak waktu ke depannya untuk lebih bisa memanfaatkan model ini secara seutuhnya. Walaupun metodologi ini cukup menjanjikan, cuma tanpa adanya historical data yang baik, maka model ini pun tidak bisa apa-apa. Jadi kita harapkan pemangku-pemangku data, KLHK dan BRG bisa memaintenance instrumen-instrumen mereka sehingga bisa menghasilkan data-data observasi yang lebih baik. Mungkin itu yang bisa saya share, Mas Agi.
Baik, terima kasih banyak Pak Adit atas presentations dan juga paparan yang komprehensif. Dan saya rasa Bapak Ibu dan teman-teman semua di seluruh Indonesia juga menaruh minat yang sangat besar ya terhadap aspek NWP karena memang sebuah hal yang digunakan dalam operasi BMKG sehari-hari. Baik, Bapak Ibu sekalian, silakan bisa mengajukan pertanyaan baik itu di fungsi chat di Zoom ataupun melalui chat live streaming di YouTube. Baik, saat ini kita sudah mendapatkan beberapa pertanyaan. Langsung saja ya Pak Adit ya, satu pertanyaan dan langsung direspon saja. Pertama, pertanyaan dari Pak Kadarsa. Pak Adit, skema parametrisasi BMJ dan Morrison memiliki nilai skill yang tinggi dibanding yang lain. Dan kenapa demikian ya, bisa terjadi secara demikian? Mohon dijelaskan secara fisisnya. Silakan Pak Adit.
Ya, terima kasih Pak Kadarsa pertanyaannya. Terus terang, kita dalam 3 tahun terakhir ini belum sampai membedah kenapa skema Morrisons itu lebih tinggi daripada skema lainnya. Nah, itu kita coba masukkan ke dalam program di kemungkinan, karena yang kita dari pengalaman kita selama ini, sebenarnya model yang cocok untuk diterapkan di BBTMC adalah model dalam skala awan atau cloud resolving model misalnya. Jadi kita harapkan kita bisa tahu sih sebagaimana pengaruhnya bahan semai yang kita masukkan ke dalam awan itu terhadap proses perkembangan awan itu sendiri. Jadi kami mudah-mudahan tahun depan bisa jalan program itu, kemudian kita bisa bedah-bedah lagi lebih dalam bagaimana skema-skema microfisis secara yang dimiliki oleh di dalam WRF secara lebih detail. Jadi saat ini kita belum punya jawabannya secara fisik kenapa skema Morrisons lebih tinggi daripada skema lainnya. Karena kita belum membedah ke dalamnya lebih lanjut lagi. Mungkin itu.
Ya, karena Batch-Miller janji gitu ya, itu memang terkadang banyak yang mengklaim performanya lebih tinggi ya di beberapa wilayah begitu. Terima kasih, saya rasa cukup jelas ya untuk Pak Kadarsa. Kita lanjut ke pertanyaan kedua. Ini Pak Adit, ada pertanyaan dari Pak Rudi Arif Satrio. WRF yang dilakukan oleh BPPT bisa memprediksi cuaca sampai berapa lama ke depan? Ini range-nya ke depan ya. Kemudian berapa presentasi ataupun akurasi ini barangkali maksudnya ketepatan forecast cuaca dari WRF yang telah dilakukan oleh BPPT. Silakan Pak Adit.
Kita selama ini menjalankan WRF maksimal 7 hari ke depan. Cuma dari pengalaman kami apabila kita membandingkan hasil running dari hari per hari, seperti tadi diperlihatkan, yang H+4, 5, 6 itu biasnya sudah sangat tinggi. Jadi kalau bisa kita bilang dari pengalaman kami menjalankan itu dan juga hasil kita observasi di lapangan, maksimal hanya mungkin H+2, H+3 prediksi cuaca itu masih cukup bisa menggambarkan kondisi di lapangan. Dan
dalam 2 inisial ya Pak Adit ya?
Ya. Tapi kita juga butuh gambaran selama 7 hari. Kenapa kita running selama 7 hari? Kita juga butuh gambaran bagaimana sih prospek cuaca selama 1 minggu atau 2 minggu ke depan. Apakah kita akan stop kegiatan sampai sini atau bisa lanjutkan ke depan. Kemudian presentasinya kita belum mendapatkan angka pasti ya, yang kita bisa angka-angka yang seperti POD tadi itu kita dapatkan dari verifikasi secara visual. Jadi belum ada angka statistik berapa persen ketepatan dari forecast-nya. Tapi untuk deteksi kejadian hujan, terutama di daerah Jabodetabek, dari pengalaman kita, WRF model bisa sampai 60-70% dalam mendeteksi adanya hujan atau tidak, tapi tidak ke intensitas berapa banyak hujan itu.
Oke, saya rasa cukup jelas ya Pak Arif. Kita lanjut ya Pak Adit. Sebenarnya ada yang raise hand, tapi kita selesaikan dulu pertanyaan di chat. Dari Pak Usman Effendi kepada Pak Adit, selain asap kebakaran hutan, faktor apa saja yang menyebabkan terbentuknya polluted cloud? Adakah ambang batas kondisi atmosfer tertentu untuk menentukan apakah suatu awan termasuk clean cloud atau polluted cloud? Silakan.
Sepengetahuan saya tidak ada ya ambang batas kondisi atmosfer tertentu. Cuma yang bisa mengakibat itu ditentukan oleh banyaknya serta ukuran dari aerosol yang ada di atmosfer. Seperti asap kebakaran hutan mungkin bisa terjadi di kalau saya bisa ibaratkan cerobong-cerobong pabrik, tapi cerobong-cerobong pabrik ini pun ukuran aerosol yang dikeluarkan oleh buangan itu tidak seragam. Jadi kadangkala itu cukup membantu proses pertumbuhan awan sendiri. Jadi tidak ada kriteria khusus bagaimana polluted cloud dapat terjadi.
Oke, saya rasa clear ya Pak Usman ya. Saya lanjut ya Pak Adit ya ke pertanyaan berikutnya. Ini kita simpan di terakhir saja. Ini ada pertanyaan tapi tidak ke NWP-nya ya. Kita ke pertanyaan Pak Indra dulu. Pada bibit awan level ketinggian berapa yang efektif dilakukan TMC? Yang pertama. Kemudian apakah ada informasi tentang efektivitas kuantitatif pelaksanaan TMC? Nah, pertanyaan kedua ini bisa disambung dari pertanyaan Pak Adi Ripaldi nih, Pak Adit ya. Saya rasa relevan karena Pak Adi Ripaldi menanyakan pada setiap episode keberhasilan TMC, BPPT selalu mengklaim berdasarkan volume air hujan ya, bukan pada tinggi curah hujan. Dan ini asumsinya mungkin pendapat Pak Adi dianggap kurang fair ya, karena volume air hujan didapat dari tinggi curah hujan kali luasan wilayah. Semakin luas wilayah yang diasumsikan hujan, maka nilai volumenya semakin besar. Nah, ini barangkali bisa dijadikan satu jawaban, Pak Adi. Silakan, Pak Adi.
Oke, terima kasih. Saya coba jawab pertanyaan Pak Indra Lestari dulu ya, Pak.
Ya.
Ada bibit awan level ketinggian berapa efektif dilakukan TMC? Sebetulnya yang kita lihat ketebalan awannya itu sendiri, Pak. Tidak di dasar awan berapa. Dasar awan cukup rendah tidak menjamin bahwa proses microfreeze di awannya itu awannya aktif. Yang kita cari adalah ketebalan awan dengan minimal ketinggian sekitar 4.000 feet sampai dengan 5.000 feet. Jadi misalkan dasar awannya kita observasi sekitar 4.000 feet, topnya hanya 6.000, 7.000 feet. Nah itu mungkin belum masuk kriteria kita sebagai awan yang cocok dilakukan TMC karena proses updraftnya kurang ada. Ini kalau awannya lebih dari pengalaman kami, ketebalan awan lebih dari 4.000, 5.000 feet itu lebih efektif dilakukan penyemaian awan. Jadi top awan sekitar 9.000, 10.000 feet. Kemudian ini pertanyaan yang mungkin cukup sering ditanyakan kepada kami, efektivitas pelaksanaan TMC secara kuantitatif. Terus terang kita selama ini mengevaluasi TMC dari data-data kualitatif. Salah satunya data dari GSMAP tadi. Kita menghitung volume curah hujan yang terjadi dilihat dari data-data GSMAP. Memang metode ini tidak sempurna, cuma kita coba batasi perhitungan luas curah hujannya. Jadi kita tidak menghitung total luas hujan itu dari semua luas wilayah target. Kita hanya dari setiap pelaksanaan penyemaian awan kita menandai ya, di mana sih kita membuang bahan semai itu. Jadi begitu kita turun, kita lihat posisi titik yang kena di GPS dengan data GSMAP besok harinya. Jadi hanya di titik itu yang kita hitung luas wilayah dengan mempertimbangkan kecepatan angin juga, arah dan kecepatan anginnya. Tentu cara ini ya benar tidak dibilang tidak fair. Pertama, data GSMAP sendiri belum tentu merepresentasikan jumlah curah hujan yang jatuh di situ karena dia hanya mengambil dari nilai puncak awan. Bisa jadi awan yang sangat dingin terdeteksi memiliki nasihat curah hujan yang sangat besar, tapi pada realitinya di lapangan curah hujan yang terjadi ya sangat kecil. Gitu. Kita sebenarnya membutuhkan analisis fisis yang lebih baik. Kita pernah di negara-negara lain evaluasi TMC itu dengan menggunakan daerah target dan juga daerah kontrol. Jadi setiap penyemaian awan di daerah target ada juga daerah kontrol sebagai pembandingnya. Cuma di daerah tropis seperti kita sekarang ini dari pengalaman kami sangat sulit untuk menemukan daerah kontrol yang kondisinya sama persis dengan daerah target. Walaupun topografinya sama tapi pola anginnya berbeda. Jadi itu belum kami lakukan. Sebenarnya yang paling pas itu kita evaluasi dari data radar. Kita cuma keterbatasan kami hanya punya satu X-band radar yang bisa melihat pertumbuhan awan dari sebelum hujan. Sedangkan awan-awan radar BMKG rata-rata C-band dan ekonya itu sudah merupakan hujan. Jadi apabila kita gunakan data radar C-band, proses evaluasinya mungkin agak kurang.
Pak Adit, mungkin sekalian saja menjawab, ada pertanyaan tambahan dari Pak Adi tadi, bagaimana membedakan kejadian hujan dari produk TMC dengan kondisi hujan alamiah? Mungkin bisa disambung dari statement terakhir tadi.
Terus terang kita belum bisa membedakan ya Pak. Bedanya hujan alami yang terjadi dari proses alam dengan proses intervensi yang sudah kita lakukan. Kita tidak bisa bilang pasti bahwa hujan ini adalah hujan hasil TMC, sedangkan hujan yang itu bukan hujan hasil TMC karena itu tadi kita tidak punya daerah target dan punya daerah kontrol. Yang kemarin yang kita lakukan adalah kita men-trace pergerakan awan yang kita semai. Di saat kejadian banjir Jakarta, kami didukung teman-teman di satelit ya, satelit dari BMKG, kami di-provide data raw radar per 10 menit. Jadi saya cocokkan dengan track seeding kami. Jadi awan yang kita semai itu kita pantau seberapa jauh dia berkembang dan akan menjadi hujan hingga luruh. Dan kemudian kita lihat dari eko awan lainnya di bidang lain. Itu yang coba kita lakukan di saat ini masih di internal kami.
Oke, karena keterbatasan waktu, mungkin satu lagi pertanyaan Pak terkait dengan GWL tadi Pak. Ini ada Pak Roland dan Pak Dimas menanyakan tentang titik prediksi GWL dan aksesnya. Silakan.
Nah, untuk GWL tadi kita diskusi dengan ahli-ahli gambut. Ada yang bilang satu stasiun itu bisa mewakili satu KHG. Cuma pada kenyataannya dari BRG sendiri mengatakan tidak bisa seperti itu. Jadi ada KHG-KHG tertentu yang hanya berjarak misalkan 20 meter, tapi kondisi water levelnya sangat berbeda. Jadi kami di pengembangan model tersebut tidak menginterpolasikan satu titik pengamatan ke misalkan satu KHG atau ke satu kabupaten. Jadi kami hanya melihat kondisi di titik itu tersebut kan untuk menghindari bias yang ada, karena lahan gambut sendiri memiliki karakteristik yang sangat khas ya, sangat berbeda. Jadi tidak bisa kita mengambil luasan wilayah yang diwakili oleh titik pengamatan dari satu stasiun bisa mewakili misalkan satu luas KHG gitu.
Oke. Baik. Sudah ya Pak Dit ya?
Ya.
Baik. Bapak Ibu sekalian, karena keterbatasan waktu dan juga sudah masuk waktu zuhur, saya rasa beberapa pertanyaan yang mungkin belum terjawab nanti bisa langsung disampaikan ke email ya Pak Dit ya. Sebagaimana yang tadi sudah disampaikan di awal, dan perkenan Pak Adit untuk bisa merespon. Untuk itu sekali lagi kita ucapkan terima kasih banyak Pak Adit dan aplaus untuk Pak Adit atas paparan dan juga jawaban dari pertanyaan-pertanyaannya. Terima kasih Pak Adit.
Terima kasih.
Baik, Bapak Ibu sekalian, demikianlah sesi general lecture dari Dr. Adit terkait dengan NWP. Semoga bisa memberikan pengetahuan dan juga inspirasi dalam mengupayakan pendeteksian kondisi cuaca dan juga potensi cuaca ekstrim ya di iklim ekstrim dan juga cuaca ekstrim di Indonesia. Dan saya rasa kolaborasi terbuka ya Pak Dit ya ke depan ya, dan teman-teman WTMC juga sangat aktif dan berpengalaman di daerah. Baik, sekali lagi terima kasih kepada Bapak Ibu sekalian atas atensinya dan juga pertanyaan yang telah disampaikan. Semoga bisa memberikan manfaat bagi kita semua. Untuk itu, sesi selanjutnya saya kembalikan kepada tim panitia. Sekali lagi, makasih Pak Adit ya. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Ya, terima kasih Mas Agi atas kontribusinya sebagai moderator. Terima kasih Pak Adit selaku pembicara.
Sama-sama Pak Subari.
Teman-teman, mungkin saya sedikit menyampaikan pengumuman buat teman-teman peserta. Sekaligus juga panitia, besok kita masih akan ada sesi yang mirip dengan hari ini. Pagi kita akan ada evaluasi dari Pak Sidney, dari Ibu Kapus Litbang dan juga Pak Kapus Piper. Kemudian nanti sekitar 8.20 sampai 10.30 kita akan ada paralel kelas Climate Science dan kelas Ocean Science. Kemudian siangnya kita akan ada general lecture lagi seperti itu. Pak Mas Arief, ada tambahan info untuk teman-teman peserta?
Belum ada.
Oke, siap. Kemudian info untuk kelas pagi evaluasi dan ocean menggunakan link yang sama. Sementara untuk climate science nanti akan diberikan pengumuman berikutnya. Mungkin itu Bapak Ibu semuanya, para hadirin pembicara, kepada moderator, teman-teman semua panitia, Bapak Ibu pejabat, Ibu Kapus, Bapak Kapus. Terima kasih. Mungkin karena waktu sudah turun, kita akhiri sesi ini ya. Terima kasih. Sampai jumpa lagi di sesi besok. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.